Okay, guys, let's go ahead and get started. So, welcome to the SecurityX CASP 005 course. We're going to start off by going over domain 1.1 in our CompTIA Security S exam objectives. It's going to take me a while because I'm used to saying CASP, but now I have to say SecurityX. So, let's just quickly go over the exam objectives here just to see what we're looking at. So, we have 4 domains in the CompTIA Security X exam. And here's the percentages on each exam. So obviously, we expect if it's 31% of domain 3, that's going to be our heaviest topic, right? So looking forward, domain 3 is going to be probably our longest slide deck. And then today we're going over domain 1, which is governance, risk, and compliance. And then these are the subdomains here. So we have domain 1.1, .2, .3, .4, and .5. So day 1, I'm hoping to at least get through most of domain 1. We may take a pause at domain 1.5 because it's kind of I'm not going to say it's easy or simple, but it's of the more easiest ones in there because it's just going over AI and like the different threats of AI, and it's kind of new, so it's not as solid as the other exam objectives. So that being said, let's go ahead and just get started here. So we're going to start off going over domain 1.1. And the first section of domain 1.1 we're going to do is going over security, program documentation, and program management. So like I said in my intro, in case you missed it, is that the SecurityX is a high-level exam. It's a professional level cert from CompTIA, but it is still technical. So what we're looking at here is as a cybersecurity engineer or the senior cybersecurity engineer is how do we look at the documentation within our organization, and is it up to date? Because as a senior cybersecurity engineer, it's everyone's job to document. It's everyone's job to follow the SOP, but it's going to be our job as that senior cyber engineer to at least advise, our IT managers or management, whoever is in charge of our program, our corporate structure, on how cybersecurity SOPs and documentation should be, or how you should look at, or what frameworks you should look at, right? So if we're in like the financial industry, we need to be looking at PCI. If we're in the health industry, we need to be looking at HIPAA. So let's just go ahead and get started here. So here are all the objectives in domain 1, and in the red, that's what we're going to be going over. So security program documentation and security program management. Big emphasis here on awareness and training, and then other things we have to know as a cybersecurity engineer that is SecurityX certified. So starting off here, security program documentation. Now, when I think about this, right, a security program, what does that mean to me as a cybersecurity engineer? What it means to me is that I'm in an environment in my enterprise where it's my job to make sure that we are secure, that we're doing our defense in depth, and that we're looking at all the different frameworks when it comes to risk management and cybersecurity, and that we have the right documentation and policies for our organization. It isn't always just ones and zeros, setting up a firewall. It's my job as that senior cybersecurity engineer to say, okay, look, I need to create policies for people to follow. I can't just let my system admins, my net engineers, or my DevOps engineers go out there and try their best at guessing how to harden or how to secure their applications or devices, right? So that's our security program. We need to put together some sort of security program within our organization that has something like a policy. So a security policy is a high-level statement that defines what the organization expects and requires regarding security. A good example of this is an acceptable use policy. So I have one right here. It's actually clickable on a link. Yes, we can leave Canva. That's what I use to make my PowerPoints. And it just shows you an easy AUP template. So acceptable use policy defines how our IT equipment should or should not be used, right? So pretty basic. If you've ever worked anywhere really that has IT systems, computers, you probably have signed an AUP. So policies should be mandatory and enforceable. So what we mean by that is, depending on our industry, our policies should support, our data sovereignty, our data governance. And what I mean by that is, again, if we're in the healthcare industry, our policies are going to take direction from the things that govern us, which would be something like HIPAA, how to protect PHI, protected health information. So right here, you see it says the policies are mandatory and enforceable. They support legal, regulatory, and contractual requirements to provide a basis for disciplinary action if violated. So going into like policies for the basic user, right? And that's why I have that example up here of our acceptable use policy. It's like, if you misuse our IT systems, if you misuse data, if you leak data, whether it's intentional or non-intentional, what are the consequences of that? It needs to be written in plain language, black and white, for our users to understand and for other cybersecurity engineers and administrators and analysts to understand. Okay, procedures. So this is getting more into less about like a policy for the user or a policy for our organization, and more like, what do we do if this event happens? What do we do if one of our employees gets a phishing email, and what's our SOP and procedure if they fall victim to a phishing email? What do we do during, we catch data exfiltration? So many different things can spark or, reference an SOP when it comes to cybersecurity. What are our procedures for different events and triggers that happen? So procedures describe how to carry out security-related tasks in a consistent and repeatable manner. So policies define what must be done. Procedures define how it is done. So maybe in our AUP, and we have a policy that says, okay, this user took sensitive data, whatever that sensitive data is, PII, PHI, credit card information, whatever. Well, if it's credit card information, that's a little bit more drastic, but whatever it is, and they accidentally put it on their personal Dropbox. You say, how do you do that accidentally? Well, maybe they're just trying to get work done from home. They're being a proactive employee. So in the policy, it says maybe for unintentional, we just do an audit and they do cybersecurity awareness training again. So now we know that as a cybersecurity analyst, we say, okay, so how do I perform that audit? I've been in organizations where an account audit is just looking at logs, maybe an event viewer on their computer. But what do we do here? That's where the SOP should come in handy. That should tell you how to do something, right? Okay, it was unintentional, so they need to do cybersecurity awareness within 5 days. So are my SOPs to email the employee in a specific email format and CC their management? That's part of our SOP. So procedures are mandatory and directly traceable to policies. They reduce errors, eliminate guesswork, and ensure consistent security outcomes. So, without those procedures, if you just leave it up to human interpretation, a cybersecurity analyst could tell one employee something, and then another analyst could tell another employee something. And then that's how we get this rumor mill like, oh, I accidentally messed something up and, I plugged the USB in, but he said this. And another employee says, well, she said that happens when you plug in a USB. So you always want to reference your procedures, whatever your SOP is for your organization. And again, those are driven from your policies or really created from them. Okay, standards. So standards now kind of does get more into maybe your industry, but also what do we reference? As a cybersecurity engineer, yeah, maybe I go to college for cybersecurity. Yeah, maybe I get my certs. But is that going to tell me day to day how to harden and operate as a cybersecurity analyst? Yes, it can, but we're not going to say, I learned this in SecurityX, so that's what we're going to do. No, what we have in cybersecurity is frameworks. We have different frameworks that we use to standardize our cybersecurity in our organization. I'm using very broad here, right? Because it's very broad standards. So as an organization like in the DoD, which for everyone in the Zoom call you may be familiar with, NIST, right? We get standard technical implementation guidelines that are developed by NIST. We look at NIST, RMF, and CSF to guide us on how to properly harden and do defense in depth for our organizations, for our different types of networks, right? So standards define specific measurable requirements that must be met to comply with a policy. So if I build my own cybersecurity organizational policy, whatever that is, the AUP, it's how to handle data properly, whatever that policy is, whatever we call it, right? You typically don't just want to fly by the seat of your pants with it, right? You want to reference something, a well-known standard that's used throughout the industry. So in the example up here, I have NIST, but there's other standards we could follow, like CIS or ISO standards, right? So a standard that you could derive from there could be your password policy, right? Could be your account lockout policy, could come from a standard like the NIST RMF or the CSF, Risk Management Framework and Cybersecurity Framework. And we'll get into the differences between those two, right? But that's what a standard is. Okay, guidelines. So guidelines provide recommended practices rather than mandatory requirements. So again, like working in the DoD, we have to abide by NIST, which is essentially NSA standards, right? And that's put out by DoD policy. Okay, cool. But what's a guideline? A guideline is a little bit more informal. It's kind of like, what's the best way to do this? So maybe a policy says you need to implement zero trust. So you go read the NIST 800, special publication 800-207. I think it's a zero trust architecture. And you say, okay, I know I need a policy enforcement and decision point. We'll learn about zero trust too. So I know I'm getting a little ahead. So you say, okay, I know that. I have Active Directory. I have Azure Entra ID. But what's the best way to enforce contextual awareness at my policy decision point and enforcement point? Well, then you may reference a guideline. You may say, hey, okay, well, here's how Microsoft tells me to do this. Here's how Microsoft tells me the best way to implement zero trust architecture, standards, right? So that's more of a guideline. It's just like, how do you do it? How do you implement this hardening? How do you implement this defense in depth for these types of systems? You have a Linux-based system, so you may do it this way to enforce, maybe RBAC or least privilege or whatever is in your policy, mandatory access control. Or in a Microsoft environment, on-prem, maybe a little different than the Microsoft environment in the cloud in Azure Entra ID. So you may have different guidelines for both to meet that same standard, which is the policy in your organization. All right, cool. Got through all that. Now let's go over awareness and training. So first we're going to talk about phishing, security awareness, and social engineering awareness. So really when it comes to awareness and training, I like to think of this as a program that we implement, we enforce, and we recommend to our organization. Now, a lot of times cybersecurity, we know we're not the enforcers, right? In some environments, maybe we are, but a lot of environments up to management. So really you recommend to management, hey, if you want to stop phishing attacks, you want to stop social engineering attacks, you don't want any insider threats, you want your users to be aware of insider threats, we need to put together a training program. So that's awareness and training in an organization. Something that a lot of times people outsource, but it could be something that you develop in-house as well. It really just depends on what kind of organization you're running, the scale. But awareness and training should cover the following fundamentals. Teach the following fundamentals for your basic user. So of course, phishing. So phishing is one of the most common techniques used by adversaries. In here, unlike Security Plus doesn't get into smishing and vishing, but phishing kind of covers all that. It's, fooling someone, getting someone to give up their credentials over a text message saying log in to pay your tolls. It could be an email saying download this gift certificate, you won this, whatever the case may be, and you click a link and that hyperlink downloads malware. Okay, that's phishing. And we need our users to be aware of that. Again, because of just constraints of time, I'm not going to go into, at this email, you want to look at the metadata, you want to look at that domain. I'm not going to put together a training program for you here in this course, but that's essentially what it is, right? Security awareness. So general security awareness. This is just maybe you want to give that user foundational knowledge to maybe not only protect them in their corporate life, but in their personal life. Because the corporate structure, we should be enforcing multi-factor authentication already, right? It should just be a done deal. But we may need to teach them about safe data handling practices, telling them, hey, here we're really locked down, and the only USBs you can plug into your computer are ones you order from the IT department. And they're going to have it's not like a MAC address, I forget what it's called now, but essentially a code that is embedded to our EDR or antivirus system that's on all of our endpoints that will allow that USB and we won't block it and you won't get a security incident, right? It establishes a baseline level of security across the organization. Okay, social engineering awareness. So this is just saying, hey, social engineering is kind of the driver behind these phishing attacks. You put together a phishing email, you're trying to fool someone, you're trying to impersonate, you're trying to appeal to authority or to trust. That's a lot of social engineering techniques that we don't dive into here in this course, but we want to teach about them. Where if someone's calling saying they're from the help desk and you need to help them with the CEO's password, whatever the case may be, that seems fishy, right? You should be aware that you're probably being socially engineered. Okay, privacy awareness. So just ensuring that your employees know what personal data is and how it must be protected. Great thing is just go over PII, right? What is PII? That's your social security numbers, that's addresses, that's birthdays, that's things like that you want to make your employees aware of. Operational security. So operational security awareness teaches users how small pieces of information can be combined to create risk. I wish, I had it saved and I don't know where it went, but I was just on Threads, right? Social media app where it was obviously a bot, right? Like it was a pretty girl that said, it's a bot though, right? It's probably based out of Russia that says, what's everyone's favorite childhood memory, or your favorite childhood dog? Post pictures and names. And people are replying. And I saw one reply that's like, this is obviously fishing for information. That's what it is, right? Operationally, I was already aware, like, wait. If someone's asking me these tiny bits of information, they're probably trying to build something. They're trying to footprint, right? They're trying to build a case for something. And whether that's like your security questions, right? That could be to build like, oh, how do we reset someone's password? And we got all these information because they're posting online about their entire life, their childhood, their favorite school, their favorite food, whatever the case may be. That's building something. So operationally, you need to be aware of that. Or someone asking questions about the company you work for, right? Situational awareness. So situational awareness focuses on recognizing abnormal or suspicious activity in real time. So just unusual behavior, maybe a fellow employee asking too many questions about a program they may not have access to, and you know that they were unhappy with the company or they're going through hard financial times. You need to be aware of that. We need to teach our employees how to be aware of that. And also the proper way to report that, because I've worked with people that everyone's an insider threat to them, when really it could just be, water cooler talk and we're complaining about our bosses. It doesn't mean you're an insider threat, right? So you got to kind of be aware of what truly is the signs of that. Okay, so security program management. So in our security program, we may want actual like black and white data of how to communicate and how to report and what your responsibilities are in case of an incident or a cybersecurity incident, and how your organization wants you to be. So communication. So sometimes this is called a communication report or a business communication report, and that pretty much will outline what stakeholders you engage and what the expectation is of how to communicate with employees and external entities. So communication includes policy distribution, training announcements, incident notifications, and risk messaging. So some things I didn't just cover, right? Besides just talking to stakeholders of a security incident, a communication plan or communication across your organization could be how you engage your users for training or how you get the policies to the users. Is there a central place where they can look those policies up so there is no, well, I didn't know how to get to it, right? And a lot of times you put that as part of onboarding, right? Hey, if you need to access this or reference this policy, do it during onboarding. Okay, reporting. So reporting provides visibility into the effectiveness of security governance. And this is just, at its basic form could be a monthly roll-up of all your vulnerability scans, all the different incidences that happened, and maybe some risk metrics. Now, is there a one-size-fits-all policy for this? A lot of times, no. It's going to be based off the organization you're in. In the DoD, we have EMAS, we have Tenable ACAS scans, we have STIGs, and all that gets reported into EMAS, right? And then we have an ISSM, some GS15 somewhere that says, yes, this POAM is fine. If you don't know what POAM is, I can't remember the acronym, but pretty much saying like operationally, we need to let this risk or vulnerability slide, right? We're taking on that risk. So a lot of times it just depends on the organization, how well you report this and what goes in there. Okay, management commitment, and then we'll go over RACI, or I think it's RACI, I can't remember, but I'll go over this. So management commitment. So security governance cannot succeed without management commitment. What we're saying here, like I've been saying, is a lot of times as a cybersecurity engineer, we don't really enforce things. We can't say that, hey, user, you must do this on our own. Our authority actually comes from management, right? So you may say, what do you mean? I create the policy. Yeah, you may create the policy, but management's commitment is what allows you to enforce it. So I always say, we advise, management enforces, and then we report, right? So yes, you may be able to tell a user that is allowed or that's not allowed, but it's allowed or disallowed because management put their stamp on it, right? At whatever level that is. In the military, that's the program office, that's the GS15. In the corporate structure, if that's your CISO, if that's the CTO, or even the CEO. Sometimes it does go up that high because you want total ownership and responsibility that says, nope, the CEO said you can't do this. That is the policy, right? So you need that management commitment. And a lot of times, if you're in an organization that isn't focused on cybersecurity, they may look at like information assurance and the cyber role as kind of like a hindrance on the organization. So it may be hard to get that management commitment. On the flip side, you could have an organization like in the military where, no, cyber is important, and we don't have our authority to operate unless we enforce good cybersecurity standards in accordance with our NSA, DoD, NIST policies, right? So I've been in both organizations. I've been in both sides of that camp, okay? But at the end of the day, you need that management commitment. So a RACI matrix. So this is a governance tool used to clarify roles and responsibility for security activities. And I'm really sorry. I don't know why I can't think of what the acronym stands for now, but I know what it is, right? So the best way I describe this is in the cloud. So what do we have here? So we have Azure and AWS here defining the customer responsibilities and the cloud service provider responsibilities based off their service models. So these are two RACI matrices provided by that CSP, that cloud service provider, that pretty much defines what your role is as a customer and what their role is as a provider. Now, this could also be done within an organization where it doesn't have to be you're going to provider to get this. You could put together a RACI matrix saying during security incidences or during onboarding or offboarding or audits, we have a RACI matrix that says what organization, what people, and what roles are responsible for what, right? What task, what process they're in charge of. Now, I just like to use this one because it's pretty common not that it is pretty common. It's what you have in the cloud. You have that customer responsibility matrix. Really, it's a RACI matrix, right? Okay, awesome. So now let's go do our quiz. Let me pull this up. So the link brings you to the actual lesson here if you're going off the slides, like if you're downloading the slides from the Google Drive and following that way, or whether you're following along here, guys. The quiz is down here, okay? Give me 1 second. Let me just bring something up. One sec, guys. Wait. All right. Let's do this quiz. Okay, question 1. Why is visible management commitment critical to effective security governance? Okay, I like how this used visible, right? So why is visible management commitment critical to effective security governance? So it allows security teams to bypass formal documentation. Obviously not, right? If management commitment means we can't do that, they're enforcing it. It reinforces security as an organizational priority and supports enforcement. I'm probably going to go with B just off rip, but let's read the other ones. It ensures technical controls are properly configured. That's true too. But when I hear security governance, I kind of think of that as like a high level, right? I think of that as like governance as in, oh, hey, we need to follow HIPAA rules here. Or in Europe, we need to follow GDPR, right? D is it eliminates the need for user awareness training. No. So obviously not A or D. Between B and C, and I'm going to go with B here. And then here's our explanation. So yep, it reinforces security as an organizational priority and supports enforcement. Question 2. Which statement best describes the primary purpose of security awareness and training programs? Okay, so security and awareness training, we educate our users, right? It's to not let them know, to tell them and inform them of what they should be aware of on our network and their personal life, and not fall victims to phishing attacks, social engineering, things like that. So it's not to replace, it's not to eliminate. That's never going to happen. Human-related security risk is whole security risk, right? Usually you get a malware in your environment, it's not because a robot did it. Well, maybe who knows now, right? AI could be soon, but it's C, right? It's to educate users so they recognize threats and act appropriately. So yeah, Jeremy, it's C. Good job. There's the explanation. Okay, question 3. An organization requires all user passwords to be at least 14 characters long, include complexity requirements, and be rotated every 90 days. Which governance component defines these requirements? Okay, so this one is... this one's a little confusing, right? So let's think of things from an engineer perspective. So if I'm putting, like, it needs to be this, right? It needs to be this. Is that a policy or a standard? So we probably have a password policy that says it needs to be complex, right? But not all the time does a security policy really outline exactly bit by bit how it's supposed to happen, right? And a policy may say reference NIST RMF, right? Reference this thing, this standard to define your policy, your password requirements. And I think, and if you look at this question in terms of like a service provider, that would be a standard. That's what I'm going to go with. If you picked C, it's, yeah, right. Off rip, I would think C or A. Requires all user passwords to be at least 14 characters. Which governance component defines these requirements? I'm going to go with A here just because it's being very specific, right? A policy may say, and again, in the CompTIA world, right, this may be standard, but when you go work and you're an actual cybersecurity engineer, you may not have to have these black and white defined things that are like, oh, hey, my password policy says it needs to be complex. Reference this standard that says it needs to be exactly this. It may just be all wrapped up into one fucking document that says policy and standards, right? So for all you guys out there in the real world, like if I have any ISSOs or E's, you know, CompTIA is not going to be a one-for-one how we do it in the DoD. But we're trying to pass this cert, so that's the kind of the mindset I want to put you in. So it was A. So question 4. During a security incident, confusion arises because multiple teams believe someone else is responsible for containment and communication. Which governance tool would best prevent this situation? So people didn't understand their roles and responsibilities. So that's going to be D, a racy matrix. We just went over that, right, with cloud service providers where we say, what's the customer responsibility and the cloud service provider responsibility? That's going to be D, racy matrix. Okay, question 5. An organization wants to formally state that all access to systems must be granted based on business need and least privilege, but it does not want to describe technical implementation details. Okay, so I'm already thinking this one might be C. Sorry, which governance document is most appropriate? So this is kind of nice, kind of clears up the question before, right? This is saying, hey, we essentially business need, that's like RBAC kind of like role-based, or the business need could be like mandatory access control. Do you have a need to know? Then least privilege is just you only need these exact amount of permissions to do your job, essentially, right? So which governance document is most appropriate? I'm going to go with policy here. So yep, we got policy. Okay, last question. A security team needs a document that provides step-by-step instructions for responding to a malware infection, including who to notify, how to isolate systems, and how to document the incident. So, probably going to go with B here. It's between B and D, right? Who to notify, how to isolate systems. It's not best practice. It's how you do it, right, step by step. So I'm going to go with procedure, right? You would want an SOP. All right, awesome. So we are 100%. So I'm going to go ahead and take, okay, 3:45. Yeah, I need to speed it up a little bit, guys. So I'm going to go through these slides a little quicker. I'm going to put 10 minutes on the clock. I just want to give my voice a little rest, guys, and we'll come back. And I'm going to go a little quicker because I want to get through domain 1. So we'll come back in 10. Okay, welcome back. Let's go ahead and get started again. I'm going to try to get through domain 1.1 before we take our next break. So I'll probably end up going a little quicker. I don't know if you can tell, but I like to get a little bit long-winded because I like to explain things, but I know that we are on a time crunch in this 5-day bootcamp style training. So let's go ahead and continue. Okay, hold on. Let me bring up my presenter view. Hold on, guys. I like to bring my different view up on my other monitor. You can't see. Okay, so here's the objectives we're going over now. So it's going to be governance frameworks and change/configuration management. A little bit shorter, right? So not too bad this slide. So governance framework. So we kind of went over standards. Like, hey, we have NIST standards. We have HIPAA standards. We have PCI DSS. We have GDPR. And although those can be considered standards, frameworks are going to be like a little different. Where some of those things like HIPAA, PCI, they may be frameworks on how to protect, or there may be a framework within that, but it could also be policy for the government that you're living in, right? It could be a straight up government regulated framework and standard you have to abide by. So many different acronyms getting thrown at you, and it does get a little confusing on how we define which is which. And that's why I like to go by what CompTIA calls it, right? So if CompTIA is calling something a governance framework, that's what we're going to call it for this exam. Okay, so security governance and organizational requirements. So security governance is a structure an organization uses to make decisions about security, enforce those decisions, and ensure they support business goals. So key word there. I'm coming from a government background, so I hear business goals. I'm like, oh, make sure our ATO is good so we win the contract again. But when some organizations where, no, we're looking at quarterly, monthly profits, and we need to meet these margins and hit a new number, appease the board members. Even if we're a private-owned organization, we still have numbers we meet every quarter. A lot of times security governance may be okay, what's the minimum we can do to get by so we don't get a huge fine from the government or the country we're operating in. Great example is the EU with the GDPR. More on that later. So governance ensures that security is not implemented randomly or based on individual preference, but instead follows defined rules, responsibilities, and processes. So that's exactly what it is, right? Security governance when it comes to our organizations, our security governance. I'm the cybersecurity engineer. So when an organization establishes security requirements, whatever that may be, protecting customer data, high availability or maintaining availability across all of our different user-based applications or whatever our infrastructure may be, or meeting some regulatory obligations depending on our industry, governance helps you do that. It says, hey, I'm going to follow this DoD senior governance framework, which is based off NIST standards, which we have to follow. So it helps you enforce and has things that you can actually be consistent on within your organization. So governance components exist to align security with business objectives rather than treating security purely as a technical function. Now, again, that's a true statement. It's a true statement. It doesn't always feel true in the government environment we work in. But yes, it's there to say the business has this objective. Let's say we're Uber. And the reason I say that is because they had a big, attack or hack, whatever you want to call it, a couple of years ago. Then all of a sudden they hired like a bunch of cybersecurity jobs. But let's say we're Uber. What's our business goal? Our business goal is to get users to download the app and use the app and be the number one provider for that service, which is, gig work cars, whatever. That's taxi service, right? The new age taxi service. Well, to them, probably before that hack, it's like, how does cybersecurity meet that goal? How does cybersecurity help us get more users to download our app? They probably didn't think it did. But then all of a sudden you have a big data breach and it's like, whoa, this is making headlines. A bunch of nerds are talking about it on Reddit. And now maybe they want to use Lyft because of it. So it doesn't matter if it's only a 10,000, 20,000, 100,000 user hit. That affects quarterly numbers. That affects your business department's ability to go up to the C-suite and say, we're doing a good job. So now we get cybersecurity more involved, and it becomes part of the business decision-making process because it says, hey, if we don't do this, here's this risk. And if we don't do it and nothing happens, something happens. But if we don't do it and something does happen, like we get data breached, then that does, that ruins our brand name, and we lose users, and we lose potential money, and we don't meet the quarterly statement. So then you go backwards plan from there. Okay, so what security governance can help me meet these organizational requirements now set by the C-suite that says, look, we want to move fast, we want to move quick, we're in the tech industry, we want people to download our app and use our app, we want high availability on it, But I also have a new business goal here because of past experiences that I can't get data breached. So we have to kind of make it highly available and do the hard job of also securing it without making it too cumbersome for the user to access the app or whatever the functions may be. So now you may look at frameworks that are a little bit not lenient, but give you those options that are maybe strict, medium, low risk, right? And so I'm being long-winded again, sorry, but that's how governance can help us. Now let's go over these frameworks, okay? So the first one we're going to talk about is COBIT. I probably should have watched someone talk about this to know how it's actually pronounced. I just mean like COBIT, right? But if I've ever talked about someone, but Control Objectives for Information and Related Technologies. This is a governance and management framework designed to ensure that IT supports business goals while managing risk. So IT, that's, yes, the cyber team, that's your dev ops, that is your system and your network engineers. Support the business goals and manage risk. Kind of like I just described, this is a framework that helps you get there. It's owned by IASCA or ISACA, the same company that does like CISM, a really high level cybersecurity sort of law that's like, equal to CISSP, especially if you look at it from like the DoD 8140, 8570 compliance. So COBIT, governance versus management. So COBIT distinguishes between governance and management. Governance focuses on setting direction, evaluating performance, and monitoring outcomes, while management focuses on executing day-to-day activities. This separation ensures that security decisions are guided by business leadership and organizational risk tolerance rather than being driven solely by technical teams. And what a great thing, right? Because maybe we've worked in organizations where we have some super genius architect, engineer, and they say that this new technology and this thing will be the best. Without ever thinking, does it make us more money or does it drive the business towards its goal? Maybe it doesn't, but it's the best. So then we implement it. We're like, okay, well, great. Now we have some tech debt. We have a system that we have to relearn, right? So I like this because this is saying, hey, and from the cybersecurity point of view, it's like, yeah, we need cybersecurity. We need to make security decisions for our organization, but don't let it just be that nerd in the closet. We need management, the people that make money, that drive profit for our organization, to say, I see what you're trying to do, but let's stand faster because that's going to get in the way of me doing my job. And me doing my job, maybe I'm a sales engineer, whatever the case may be, provide your paycheck, right? So COBIT's a great way to kind of bridge that, that internal restless, butting of heads between business and cyber. That sometimes is there. And again, these are frameworks that are they're not used in the DoD. So a lot of us, in the Zoom call, we're DoDs, so we're like, yeah, we don't care, bro. We need our ATO. But in the civilian world, it's not like that. So again, CompTIA SecurityX, we got to look at things from that point of view. So COBIT and security requirements. When an organization defines security requirements, COBIT helps translate those requirements into control objectives and performance metrics. So this framework allows us to gain some sort of quantitative or qualitative metrics. It also ensures that responsibilities are assigned, controls are documented, and effectiveness is measured over time. So it goes over that. It says build your AC matrices or build something that defines responsibility. Document your controls. It says all the things that you should do for solid cybersecurity, not just in the ones and zeros, but for, the human element and all the documentation we may have to do. Okay, so the COBIT framework, just a timeline. This is straight from their website too. It's called COBIT 2019. That's like the last major revision, or that's kind of like their don't follow anything previous to this, or we built on top of this, now we're COBIT 2019 framework, right? It's still the COBIT framework, but it's just like the latest revision. And you're like, that's, 7 years ago, but that's what's on their website still. So maybe they have more revisions. I couldn't find it when I was doing this course. So that's what we have here, COBIT 2019. Okay, ITIL. So I've always known ITIL as a cybersecurity cert that I need to go, pass my 101 classes in college when I go to WGU, but it's actually more than just a cert that's provided by PeopleCert. It actually defines how you run IT organizations, right? It defines measurables, daily processes, SOPs, and daily IT operations. So ITIL, or the Information Technology Infrastructure Library, focuses on IT service management and operational excellence. So what is this, real world? This is, hey, when I have my service desk, how do I tier it out? How do I remedy tickets? How do I do ticket intake? How well do my customers or my users know how to create a ticket? And what's my remedy times? And do I have a good process to elevate? Do I have the right people assigned to the roles and responsibilities within my ServiceNow instance or whatever my Service Desk instance is? It standardizes that. It tells you how to standardize that and how IT services should be delivered, supported, and improved. Think of this as creating user accounts, setting permissions, fixing emails, daily trouble ticket logs, and troubleshooting. That's IT. So how does this relate to cybersecurity? So ITIL's role in security governance. ITIL supports security governance by reducing operational risk through consistency and documentation. So good cyber relies on good IT, right? At my day job, we work with our cyber teams to say, how do we implement the the STIGs, if you guys know what that is, Security Technical Implementation Guidelines. How do we do it? How do we do NAs? How do we do POAMs? If a STIG breaks my network, how do you want me to write the reasoning that this is a finding, right? Things like that. And ITIL says, hey, if your IT team has good documentation, consistency, has standardized processes for, intaking tickets and resolving them, that just helps cybersecurity teams analyze and say, okay, it's easy to do an account audit. It's easy to do our functions because we have good IT standards, right? Because it's routine. So we have a lot of information that's digestible to us to look at our threat landscape, look at what we have out there. Almost like a source of truth, right? Next is change management. So from a network engineer, I hate change management, right? I just want to go in, do my thing, but we understand what it's there for, right? In cybersecurity, it's not just always hardening, defense in depth, onion layered security, highest encryption standard. It's not always that. Cybersecurity, we also care about availability. I literally just had a conversation with my cyber team today talking about, hey, we can move forward or a little faster on this thing and do paperwork after. Not in violating anything, but it's just hey, we can take on that risk, right? Because that's the organization we kind of work in. So how does that relate to change management? Why do I bring that up? Because change management reduces the risk for changes, right? Essentially, it gives us a consistency that says, hey, we did the paperwork to implement this new permit or deny statement on this ACL. And then all of a sudden, 8 hours later, we thought we did the correct test, but now users can't reach something. If we have good change management documentation, we can look at what's changed, right? They weren't having this problem yesterday, and now they are. But beyond that, it allows the entire team to be on the same sheet of music to say, we know what's coming up, we know what's going to be changed, and I've had you do your due diligence to say, here's what's going to happen when I implement this change. And guess what? Cybersecurity should have a role in that. If you're implementing an architecture change, cybersecurity should have a role in deciding whether or not that change should go through. Because maybe you're trying to make a change that may introduce a third-party library that introduces all this new risk. And if we take that, we present that to management, and we say, here's the new risk. Do you accept? Do you tolerate it? Or do we mitigate and we don't do it at all? We don't implement that third-party library. They need to be part of that conversation, because I guarantee you as a network engineer, system, DevOps engineer, we don't care, right? We're no, this thing's going to help us, so we want to use it. But cybersecurity should be a part of that. In my day job, they are. When we have this matrix, right? It's very government. It's looks like the matrix was made in the 90s, but it's helpful. That pretty much says, here's all the paperwork you need to make a change to our architecture. And if it's a tier 3 change, guess what? We need a security impact analysis. That's not an acronym that's on the test, but that's how we involve cybersecurity. We're okay, I see on this matrix, it says that if I want to change my routing protocol, that's a major architecture change. So I need an SIA to be done and filled out and approved by my cyber team before I present this change to the change management board, and they allow me to do it. So that's how we involve cyber in those changes. Okay, then asset management. So change management also involves asset management, which is great because, again, as cybersecurity professionals, we want to look at our threat landscape, right? The entire attack surface and see what we have out there. Well, what better way than asset management? Again, this is something I do in my role. ICE, we have Identity Services Engine by Cisco, and we have all of our accounts in there that use CACX to authenticate, authorize, and then does our accounting. Well, our powers to be, what I mean by that, our senior cybersecurity engineers, for those that don't know what an ISSM is, they want those logs. They want the logs of the users that are made in provision and when's the last time they logged in. So we pull that. That's asset management. That's saying, hey, that account is an asset. I want to see what accounts have been used, who's not using them, and are we doing proper audits. But beyond that, it could just be physical hardware too. It could be, hey, our asset management helps us with our lifecycle management. So if I know every single switch that's on my network, I can have a chart built out, and I can have a little Excel spreadsheet that says this version of switch is EOL end of life, 2027. We need to start thinking about upgrades because I don't want any vulnerabilities on our user-facing switches, right? So that asset management, we know it's out there. It helps us with cybersecurity functions like that. Helps us with that life cycle. Okay, and then a CMDB. So that is a configuration management database. This is a centralized repository that stores information about configuration items and their relationships. This could be something like Splunk, right? This could be something like ServiceNow that says, hey, that's a big time like help desk application that it's a whole career, honestly, ServiceNow. But we could have a CMDB in there that says, hey, here's all of our Linux, Microsoft, OpenBSD, here's all of our Juniper, Cisco, Ubiquiti switches, whatever the case may be, right? And say, and here's how we configure and manage them. Here's the last time we had an update and provision and revision on them. And that helps us identify our systems. So then if we're looking at the CISA website, CISA website that says new vulnerability came out for Cisco ASA 9.20.3, here's how to remediate. It's a CVSS score of 10. Well, big organization cybersecurity, we may not know every single device top of our head, but we know we have Cisco firewalls. So we go to our team and we say, what kind of firewalls they have? And they say, hey, here's the screen. Go check. You're self-sufficient, right? So they go to the ServiceNow, and that'd be a really douchey thing to do. But you go to the ServiceNow instance and you say, let me check my CMDB. Do I have Cisco ASA? Nope, I have Cisco FMC. Okay, this isn't important to me. So that's kind of how we can use this in our day-to-day as a cybersecurity engineer and be proactive. All right, quiz time. Let's do it. Oh, this took me to this other site. One second. Hold on, I gotta go here. This is my account that has it. Okay, so we're doing domain 1.1.2 quiz. Alrighty. So question 1. A vulnerability scan identifies a critical flaw. Hold on, so I'm bringing the chat up, guys, so you guys want to answer it. Okay. A vulnerability scan identifies a critical flaw in an application, but the security team is unsure which systems are running the application or what business services depend on it. Which governance component would most effectively help identify impacted systems and the relationships in those systems? We just talked about this, right? So it's not B or C. It's not change management records. It's not secure configuration baselines, which we should be doing, right? We should have baselines for any device out there that's repeatable. So now it's between A and D. So asset inventory, to me, is just we have this, here's its version, Catalyst 9200 switch, that's it, right? It could be a little more, it could be the operating system, but I'm going to go with CMDB. That's going to give me not just the operating system, it's going to say it may be connected to this, it's running this application, it's doing this service. So that's going to be a CMDB. And yep, sorry if I'm butchering the name, Masood, but yeah, it's D. During the break, you can tell me how to pronounce it if I'm just royally butchering that. Yep, D. Okay, question 2. An organization wants to ensure that its security controls are aligned with business objectives, that responsibilities for security decisions are clearly defined, and that the effectiveness of those controls can be measured over time. Which governance framework best supports these goals? Okay, hopefully it's not one that we didn't learn about, right? But business objectives, right? Yeah, Chandra. Sorry if I'm butchering that name too, sorry. Yeah, B, COBIT, right? ITIL was just all about like the best way to run a help desk. It didn't really even talk about, well, it does help you with business goals because it's an efficient help desk, helps you remediate things quicker, you're not wasting as much money. But COBIT specifically defines, here's how cybersecurity can help your business goals. So yep, it's going to be COBIT. Okay, question 3. A security team discovers that a production server was modified without approval. Oh, that's a no-go, resulting in a misconfiguration that introduced a vulnerability. Which ITIL practice would most directly prevent this type of security issue? Yeah, see, right? This is an easy one. Change management. Something was changed. We didn't know about it. Easy, right? So, yep. Jeremy, Masood, it is C. Change management. Let's go, guys. 100%. All righty. Let's go back here. Let's finish up domain 1. Then we'll take another quick break. Probably like only like a 5-minute break. Okay. So now we're going to go over domain 1.1.3. Okay, so domain 1.1.3, still domain 1, given a environment. This is kind of going to go over kind of like pipelines, right? CI/CD pipelines development and where we introduce data governance into it before it hits like production. So we'll get into it. Okay, so GRC. Let me bring up the other monitor I need. Okay. So that's governance, risk, and compliance, or risk management. So in every organization, regardless of size or industry, must make deliberate decisions about how it manages security, risk, and compliance. These decisions are not made randomly or informally. They are guided by structured governance processes. In cybersecurity, this structured approach is commonly referred to as GRC. Okay, so how do we do GRC? Governance, risk, and compliance. Well, first, how I look at this, right, is we got to define our industry. So let's first define our industry. Yes, we have a company. Yes, we have an enterprise, a corporation. But let's define our industry. So let's say I'm in retail. Okay, so I'm in the retail industry. So what do you think the number one point of contention or cybersecurity threat, attack surface, we want to worry about most? Well, we're transacting, right? Finances. So if we have point of sale machines, no one on the financial industry, we're in the retail industry, but one of the regulations we have to be aware of is PCI DSS, right? So that is credit card transactions. That is the standard, the regulation defined by the credit card networks, Visa, Discover, Amex, that says how you must protect point of sale machines when they're doing credit card transaction. So there's our governance, there's our compliance, and what's our risk if we don't do this? That's defined in there, right? So that's GRC if we're at a retail, and that's just part of it. If we're at a hospital, what's the industry we're in? Healthcare. Okay, so what are we handling? Health records, protected health information. What helps us define our governance for it? What's the laws of the land? What's the actual, no shit, what we can and can't do with this data defined by a regulation that's HIPAA if you're like in America. It's may define our compliance. So what do we do to be in compliance? Maybe we have to set encryption on our data at rest. Maybe for data in transit, we apply encryption as well, right? Just more like VPNs, TLS. Storing physical records, which you may think that's not a cybersecurity function, but it kind of is, right? How do we send health information? What's the standard that HIPAA says? Yes, I know I can set up an email server. We can send email and health records all day long, right? But what's the actual standard for that? So to effectively implement governance components, organizations rely heavily on GRC tools and data governance practices. Okay, so GRC tools, mapping, kind of what I just described. It's the process of linking organizational policies, technical controls, and organization and operational procedures to specific regulatory requirements, industry standards, or frameworks. I just kind of talked about that. I honestly didn't even know this was next, so I kind of got ahead of myself. Again, I just built this course in like literally 2.5 weeks, so I was just like busting it out, you know? So anyway, sorry. I'll get off track. But we need to map it. We need to map it to what we need. You know, I'm not going to look at HIPAA if I'm running a bank. And it's simple as that. Now, obviously, this can be a little bit more complicated. If you're like a restaurant, small business, it's like, okay, yeah, I need to be PCI compliant. And I need to. I'm not saying like we shouldn't. But if the mom and pop taco shop, if they go buy Stripe, I don't know if you heard of Stripe, they're fine, right? That like third party kind of takes care of all that for you, that point of sale machine. So it gets a little easier, right? But if we're a huge e-commerce service operating internationally, then not only PCI, but if we're international, we may have customers in the EU. Guess what? New regulation, GDPR. You may be a cybersecurity engineer at a big corporate retail chain like Ross, and then you go get a job working in an OT environment, operational technology environments. Well, before you worried about PCI, maybe GDPR, and now you're like, well, I'm in a dam. I'm securing this dam or this power plant or this oil pipeline. What do I start? Maybe that's an ISO. Maybe that's an international standards organization. Okay. So there's so many different ways we have to map. Maybe organizationally we say, hey, we need to be not PSI, SOC 2 compliant, right? So we got to do that as well on top of our PCI. So it's a big thing, right? How to map what regulations we need and which ones we don't. Because you don't want to say I need to be ISO 2700, PCI, GDPR, NIST RMF. I need all these compliances. Will that really work? They're going to have redundant hardening, and they may have extra hardening that makes your environment completely unavailable, right? So it is important. Okay, automation. So how do we automate our governance, our risk, and our compliance? So the most basic tool in every cybersecurity is toolkit, SIEM or SIM or SIEM system is we have a centralized place where we ingest data, whatever that data is, logs, we index, we build automated playbooks using maybe SOAR, maybe using Ansible, Python, whatever automation we want to use, API calls, and we remediate incidences as they happen based off a playbook that's going to use these type of tools based on information we're getting from our monitoring system, which could be a SIEM, IDS, or our XDR logs that are ingested, whatever the case may be, right? So high level, right? I can't go into how SIEM works and how we index, how we build a Splunk dashboard. I'd like to, but it's, hey, we don't want to manually log dive every week, go into our Linux server, look at the var/log and go to the timestamps and be like, oh, data exfiltration happened at 1 a.m., what other server, CLI? No, we need to automate that, right? Centralize, monitor, single pane of glass, and build your automation tools off that based off a set of procedures and playbooks that are well known, okay? And then compliance tracking. Again, this could be Splunk. This could be like Azure Sentinel. It's not called that now. I think it's just Microsoft Security Center. But that's compliance tracking. So maybe we say, hey, our life cycles are coming up. We need Windows 11 25 Hotel 2 now, right? So we build a Splunk dashboard that says, hey, we're going to reach out to every single computer object in Active Directory, pull it into our Splunk dashboard, and then do a call to those computers to get their OS version, come back to us, and we're going to build a dashboard. One that's green that says, here's all the computers that are updated. One that's red, all the computers that aren't updated. We have 50. We click that dashboard. It shows us what OU it's in, if we get the information from them, maybe geographic locations, and maybe some logs from those computers, and we decide how we then get them in compliance. And we track that, right? We track that with some dashboards. When you're in the SOC, Security Operations Center, we should know all about this, right? Big monitors, TVs everywhere, helping us look at our compliance. And then documentation. So this is like my favorite, right? I'm a big Confluence fan, but here's our documentation. So GRC isn't just about all this cool stuff like building Splunk dashboards, remediating things based off, building a SOAR, building playbooks, Ansible, Terraform, I don't know, anything, right? It's awesome. That's the ones and zeros. But we got to document the boring stuff. But as a senior cybersecurity engineer, one of your most important roles. Why? Because if it happened 6 months ago, it may happen again. And I fall victim to this in my own day job where we've talked about STIGs maybe 3 times in a year and things change. And I just had one of my coworkers say, no, look, this is the document we used last time, and put that out in our team chat saying, no, we already talked about this. We don't need to rehash this conversation because we documented that. Another real world one is we had a POAM, OSPF WAN key encryption or hashing, and documented exactly the reason why, whatever, can't get into it really. And then just a couple weeks ago, they're like, why are we using this? We're like, we documented this. We put this in our content management system. We wrote down why and where you agreed and said that's okay to our GS, right? So documentation is important because it allows us to know what compliance is, what was good, and if something happens again, we have something to look back to. This is essentially the documentation that helps build your playbooks and your SOPs in case of cybersecurity incidences. And of course, continuous monitoring. Kind of already talked about this, but at the enterprise level, if we want to ingest logs, look at real-time data, we have our SIEM systems, and that's for everything, right? You kind of see here how this data is coming from routers, switches, computers. I should have put a server in there, but servers, right? And it's ingesting. That could sit in line. It could sit as like a tap, kind of not in line with the network traffic. And then at our endpoints, we could have things like XDR, extended detection and response. That's essentially like the new hot. It's not new at all, but that's like the new what you install to protect your endpoints. It's like what antivirus, anti-malware was 10 years ago, which still is used, but XDR, EDR is like, we do everything, right? We have our endpoint, We're watching it, we're monitoring, we're looking at heuristic-based behavior analysis, we're responding, and we're alerting, and we may be sending our stuff to a centralized logging system like a SIEM, okay? So GRC tools integrate with security monitoring systems like SIEMs, vulnerability scanners, cloud security platforms, and identity management systems. So think Active Directory, but Enter ID, think Identity Services Engine, integrating TACX, Radius on the enterprise. Cloud, think Enter ID. I don't even know the AWS version. It's really bad. But that's how you know I work in government. Well, Microsoft. Okay. Data governance now when it comes to staging environments. So what are we talking about here? So for the non-developers in the room, me included, right? I'm not a developer. I do network automation for sure, so I understand pipelines and different environments and staging environments. But what are we talking about here? So when we're building an application, at the very basics, right, we have some sort of source control. That's like GitHub, GitLab. And that GitHub is going to be our code repository. And we're going to have what's called a main or master branch. And that main or master branch is going to be linked to all of our production, like backend servers or databases, whatever, right? That's our code that builds that website or builds that application for us. And that's the code for it. So we call that the production environment. That's our main master branch of that source control management in GitHub. And that's what's mapped to, our web server application, front end, back end, and then like our MongoDB database, our Mongo database, okay? So that's where live systems operate and where real users interact. So data governance might be the most important here, right? Where if some user's accessing our application, we need access controls. We need encryption for data at rest. If we're transacting, it's a web server. We need strong TLS encryption, maybe TLS 1.3 ECH, right? We need logging and monitoring in that production live system. That's where we're going to see the most hardening, the most security presence, that most defense in-depth approach to it. Production could be your web application, or production could be, in my world, where it's an entire network, right? That's where we have the most compliance. That's where we have the most data governance. And any failure in production could lead to what? Data breaches, security incidences, events, right? Cybersecurity events. Okay, and then development. So what's the development environment? So the development environments are what it's used by, you guessed it, developers, whatever, automators that help you build and modify your application without affecting production. So data governance and development. I like to say you don't need it, right? Build your app, make it workable, and then bring cybersecurity in. But let's just see what CompTIA has to say, right, on the slide deck. So from a governance perspective, development environments require controls that balance security with productivity. Developers need flexibility, but unrestricted access to sensitive data creates significant risk. So what we're saying here is like, hey, you can't develop and use real information from like your production database. That's what we're saying here. And then in development environment, we want to at least have a conversation into bringing cybersecurity in, having some sort of governance in the development stage, because that may make it easier when we get to the testing stage where we say, hey, now we're going to run this application in a runtime environment, and here's where we may do some like dynamic analysis against it, some fuzzing. We're going to see if our access control methods actually work, adjust our rules based off this testing environment, right? And then Q&A, I like to say this happens before we go into production. So Q&A, quality assurance is, as cybersecurity professionals, we say, hey, is it available after we implemented our hardening, our security in the development phase that moved to testing? And then last thing before we put it into production is a Q&A, right? So, okay, does it do this little thing? And this is like a whole chart of basic functionality down to, anecdotal use case functionality. That should be our Q&A. So data governance and Q&A emphasizes controlled realism. Data should behave like production data without exposing sensitive information. Governance policies define what type of data are allowed, who can access it, and how long it can be retained. Okay, data lifecycle management. You see here, I took this from my actually Security Plus slides where I did this, pretty much had this image 6 times and read one on each time. Our data. When we say our data, let's say we're running an e-commerce server, user creates an account, does orders, and we track all that stuff, right? Well, what's that lifecycle management? Maybe I'm on a secret network and I'm building product or whatever. Maybe I'm in a sensitive environment in a corporate structure and I'm building a product, whether that's a white paper, an application, whatever it is. How do we go through that data? How do we destroy it? How do we store it, use it, archive it appropriately? So we have to have some sort of data lifecycle management program in place. So in governance, this is kind of like how I like to look at it: create, store, use, share, archive. and then destroy. And at each section here, how are we protecting it? Are we encrypting it a certain way here? Where do we store it? Do we have redundancy on that storage? Do we have synchronous, asynchronous storage between maybe like a region in the east and a region in the west if we're storing something in the cloud? How do we use that data? And if it's data in use, are we protecting it in any way? How do we share data, maybe with B2B, external, customers, whatever the case may be? And then we're done with the data. How do we archive it? So whatever the data is, right? How do we archive it properly? And then how long do we have to retain it before destruction, right? So that's a basic data lifecycle management. Where are we at? Okay. Let's do this quiz, then we'll be done with domain 1, and then we'll take another break because I need to rest my voice just a little bit. Okay. Long questions here. Okay, question 1. Let me bring up the chat. 1 second. A development team is building a new customer-facing application. To speed up testing, developers request access to a copy of the production database containing real customer information. Ooh, scary, right? The security team denies the request and instead provides a data set that preserves data structure but removes sensitive details. Which data governance principle is being applied in this scenario? So straight from the slide deck, this question looks like. But yeah, that's controlled realism in staging environment. So pretty much we're saying, hey, as a development team, we want to make sure that live prod or the live database works with these changes we're making. So we want a copy of the live database. So you're in some really locked down environment where I guess you don't have complete access to your database as a developer. And security team says no. They say, hey, I get it. But what we'll do is we'll just recreate a MongoDB database and maybe we'll obfuscate or mask the sensitive information because we don't want you to have that sensitive information from real life customers, right? So that's controlled realism in staging environments. We're not destroying here. We're not going to the create, share, use stage. We're not, it's not really monitoring, right? We're in development stage. And it's not a regulatory mapping. So we're going to go with C. Okay, question 2. An organization is required to comply with multiple regulatory frameworks, including HIPAA, PCI, and ISO 2700. The security team has implemented encryption, access controls, and logging across its systems, but auditors report that the organization cannot clearly demonstrate how these controls satisfy each regulatory requirement. Which GRC capability would most effectively address this issue? So pretty much we followed a bunch, again, I'm like, when do you need to do this? I guess in a hospital you could at the cafeteria buy some stuff. I don't know. Well, right, yeah, PCI because you have to pay. We're in America. We don't have free healthcare, so we got to pay for shit. So maybe PCI will come into play. But essentially, an audit said, no. I get you have these things, but you didn't clearly map them to which framework, right? You didn't clearly map them to which framework. So we talk about a GRC capability. We have automation, continuous monitoring, and mapping, and compliance tracking. Well, right, this isn't really compliance tracking because we tried all this, right? Before we track our compliance, we need to know which ones actually effectively we need in our organization. It's not automation. Nowhere in here we talk about automation, right? Continuous monitoring, it says that we implemented logging across those systems, but logging doesn't equal monitoring. That just means we're building a log that then we then have to have a system that looks at them. So the best one here is going to be B, mapping. That's what we're going to go with because we need to see, how these controls actually relate one to the business and to these frameworks and standards and regulations that we went off. Okay, question 3, last question here. During an internal audit, a security team discovers that sensitive customer data from a retired application is still stored on backup systems, even though the data is no longer needed for business or legal purposes. Which governance concept should have prevented this issue? So essentially, we have an application, and that's retired. Pretty much maybe we still have it on the code somewhere, right? It's in our GitHub repo. Maybe it's on some server somewhere, but it's not being used. Maybe we kind of denied access from anyone, just took the IP, hosted them away, whatever the case may be. Who knows, right? Customer data from retired application is still stored on backup systems, even though the data is no longer needed. Oh no, maybe we got rid of this. What this saying? We got rid of the application, and then we have some storage or systems that still have it on there, right? Like data from it. So we did bad what, right? What did we not do well here? I'm going to go with data lifecycle management. Yeah, because it's not documentation. Maybe that would have helped us see like, oh, this title application, right? But we did bad data lifecycle management. All right, awesome. So there we go, guys. We got 100%. Okay, we're making okay time. All right, got through domain 1. So we're going to take another 10-minute break. I want to rest my voice or I'll be completely messed up by Friday. I want to keep the enthusiasm going through you guys. So let's take a 10-minute break, and then we'll come back, okay? All right, guys, let's go ahead and jump back into it. Now we're going to be going over domain 1.2. So let's check it out. Let me erase my writing here. Okay, so domain 1.2.1, or 1.2 really, I just break them up into sections, right, my domains. Given a set of organizational security requirements, perform risk management activities, impact analysis, risk assessment, and third-party risk. So here's all the objectives we're going to go over. And here's what we're going to go over in this first slide deck. So impact analysis, risk assessment and management, and then third-party risk. Okay, so impact analysis. So what is this? You know, what really helps us with this is like that asset inventory and configuration management database. But what essentially this is let's look at our threat landscape. Let's look at our attack surface. So let's say we have some sort of like legacy server that's quarantined off in its own VLAN, and it's not really running anything. And, you know, what happens if that gets, you know, what's the impact if that gets exploited? Well, we may say nothing really, because it doesn't allow lateral movement. Maybe the only thing that it's allowed to do is port 22 outbound. No, that'd be bad for lateral movement. Let's say port, 443. And so it's really hard, right? Maybe it's like literally, we are literally only allowing in and outbound this. No other port number can be used, right? So we really harden that. We compensate it. So what's the impact of that? Maybe we say low. Maybe we say, hey, the impact of this gets exploited is not something that we make priority. However, there may be some big impacts. Like if we get a data breach and we're a company that relies on trust with the public, well, there may be some big impact if we get a data breach. Perfect example of this is Okta. Remember when Okta got breached, which is literally a cybersecurity company. They're an authenticator. They're a security authenticator, centralized authenticator, identity provider, and they got data breach. That's a huge impact for whatever system got impacted and allowed that exploit, right? So impact is typically evaluated across multiple dimensions. So I'm talking about like reputation. I talk about that a lot. It's just easy, right? But that leads to financial loss. There's recovery costs. If something got exploited bad and we had to revert back to a last known good, and who knows if we've been doing good backups, you just never know. There could be more than that. Could be fines and legal expenses. So if you get like, not to say caught, but let's say the GDPR, this happens a lot. They'll fine companies for not following the GDPR, but maybe it's also how you responded to data breach was bad. So not necessarily your fault, but maybe the response was your fault, right? So let's move on here. That's impact analysis. Extreme but plausible scenarios. So something, I've never heard this in the real world, but I kind of like CompTIA put it on there. Extreme but plausible scenarios. In my mind, this is like, okay, this happened maybe one time from some cybersecurity researcher at MIT, and now it's like, hey, if these sequence of events all happen perfectly, we get the nuclear race condition, and all your systems are effed, and people are getting free stuff off your e-commerce site, right? It's the worst case scenario. So extreme but plausible scenarios. It's like, okay, how do I teach this? It's just saying, hey, if a bug or malware infects a printer, the extreme but plausible scenario there is that it somehow goes back to your cloud SaaS instance and corrupts and exfiltrates and does network egress costs towards the hundreds of thousands of dollars on your cloud instance and takes all your user data, right? That's a good example, I feel like, in my mind, where I'm like, wow, one printer got past, that malware got past all my EDR, XDR, firewall, SIEM, my web application firewall, my CASP to my cloud, and authenticated, did a multi-factor authentication. My contextual awareness didn't pick it up, and it got in there, right? So that's what I think of an extreme but plausible scenario. Now, why do we game plan this? Why do we sand table this? Because if that is your most extreme scenario and you backwards plan from that, it's kind of easy to harden from there, right? Like, nope, maybe I'm using the cyber kill chain of analysis. I'm like, no. There's no way that malware from the printer can get to my SaaS instance that I have running in Azure during this chain, because I can break the chain right here using this SIEM, this CAS, my large learning model enabled behavior analysis and prevention protocol that I have in my CAS, whatever the case may be, right? I'm throwing a bunch of buzzwords at you, but they're all cybersecurity scenarios, right? So the purpose of analyzing extreme scenarios is preparedness, not fear. It's just really doing your defense in depth. It's doing your onion layer of security at a big level, at a extreme level. And usually you might catch some simple things by doing this. I mean, we do this even like in network engineering, right? We're like, okay, we're just adding an ACL line, but we need to kind of backwards plan, like, is this going to stop our user traffic? And that's always the main goal, right? Like, will this stop the data stream that our customers are relying on? And that's our extreme scenario for putting an extra permit statement. Like, why would an extra permit statement do that? And our ACL that we're changing on like our tunnel, our egress tunnel, whatever, VPN, but it's something we think about. Okay, risk assessment and risk management. So risk assessment and risk management are related but distinct activities. Risk assessment focuses on identifying risk and analyzing their likelihood and impact. Risk management is a lot broader. It decides based off your risk tolerance of the organization, right? How to address those risks. So if you have a high, medium, or low risk appetite, may affect how you do risk management. Where risk assessment is just kind of like, no, these are the risks, and here's how these risks get actualized, right? Here's how the risks get exploited. That's it. So quantitative. So quantitative risk analysis attempts to measure risk using a numerical value, 1 through 10, 9 being the most likely. Whatever the case may be, there's a number to it. Example, CVSS scores. CVSS scores are quantitative. They describe the severity of a risk, the severity of an exploit, a vulnerability, not necessarily related to risk, but that's just an example of something quantitative that's well used throughout all cyber, right? All IT. So using quantitative risk assessment, organizations can calculate expected annual losses and compare them to the cost of implementing security controls. Think of this as like our ALE, annual loss expectancy, if this risk gets realized. So back to Security Plus days, I didn't see this on the exam objectives here, but that's like our ARO, annual rate of occurrence, plus our single loss expectancy, right? You do the math on that and you get your annual loss expectancy. So if this happens 4 times and every time it happens we lose 30 grand, our annual loss expectancy is 120 grand. That's what we estimate. That's the risk for it. That's a quantitative thing we can present to management. Okay, qualitative. So qualitative risk analysis evaluates risk using descriptive categories rather than exact numbers. That's us creating a term saying it's low, medium, or high, or critical based on our judgment, kind of like our objective judgment in the organizational context. Again, organizational context, kind of like what's your risk tolerance, what's your risk appetite. It's much faster and easier to communicate. Just say this risk is high, right? It's easy, right? Instead of like, let me think of a numerical score based off the annual rate of occurrence and all these other numerical values we could have. So most organizations use both. There's not like we must be quantitative. You can use both. It all depends on the scenario. I'd love to deep dive, but again, I want to get through everything. Okay, risk assessment frameworks. So there are frameworks for cybersecurity, and there's ones that are just for risk. And the risk management framework from NIST is a great example of that. I think I have a link in here. Yeah, let's see. You can download NIST RMF, right? It's a publication. So let's see, where is it at? This is the special publication. Yeah, so right here, right? SP 853 alpha, but that's RMF, right? That's risk management framework. How do you manage your risk? And it kind of helps you determine what your risk appetite really is in the organization. Obviously, that's a personal choice depending on management, but this can also help you with that. So to ensure consistency and repeatability, organizations use risk assessment frameworks. These frameworks provide structured methodologies for identifying, analyzing, documenting, and managing risk. So again, can help you manage it. And again, that's kind of like expectation as well, risk tolerance. So other frameworks are ISO, so International Standards Organization has one. COSO, Enterprise Risk Management, never used it. It's just one of the common ones, and something called FAIR. Again, never used it. I'm from a DoD background. That wasn't on the exam objective either. I didn't need to define those, but just wanted to throw some examples that maybe you could look up. And these help you with due diligence and maintain compliance with regulatory requirements. And again, the main goal is look at your risk, how to manage it, and you get a framework for that, saying you should be looking at these type of controls, these types of impacts. Risk appetite and risk tolerance. A couple words I've used. Now let's go over it. So, Boeing has quite the low, or, they don't really care, right? Their risk is really low. So risk appetite defines how much risk an organization is willing to accept. Theirs is high, right? Like, we'll accept all the risk. We don't care. Push that plane out. We don't care if the doors fall off. Again, this is just something that's been in the news. Not as lately, but it was. So this is a strategic decision set by executive leadership and the board of directors. This is saying, hey, this is, risk management also kind of can help you determine how they think of cybersecurity, period, right? You could tell to your face is blue we're at risk for this kind of data breach. And if the organization just doesn't care, they're like, we don't want to invest the money to protect this. It hasn't happened yet. We don't think it's going to happen. You're telling me it could possibly happen if these events line up and these threat actors look at our attack surface and attack us. Like, no, you know? So we have a high risk appetite, meaning we'll accept it. We'll accept the risk, right? So organizations with strict regulatory obligations have a low risk appetite. So that's us, right? The DoD, depending where you're at. Like for the contractors and my environment, we have our own ATO for our own kind of network. We have a low risk appetite because we want our ATO to stay, right? We don't want some doctor, GS15 or SES saying, you missed one little thing here. So we have a low risk appetite. We're like, we're not going to change quickly because we have to go through a whole approval process and add that into an ATO. And our network's working right now, right? So again, it just depends on the organization. Where startups, things that are innovation driven, where you're disrupting an industry, you have a high risk appetite because you're like, no, deploy it, make it happen, put it in front of the customer. They don't care about the cybersecurity right now. We need to get them to buy, to invest in us. So risk tolerance defines acceptable variation with the overall risk appetite. It establishes practical boundaries for operational decision making. Together, risk appetite and risk tolerance guide which risks are acceptable and which require remediation. Okay, risk prioritization and severity. Again, this is going to be organizational driven. So organizations, I don't even want to look at the bullet points here. Let's just go over this. Risk prioritization comes from the governance and comes from the organization's view of cybersecurity. If we're in a NIST environment, actually, I talk about that too much. Let's say we're in a financial environment, and the number one thing is our financial records. And we have a local share drive that doesn't have financial records on there. Maybe it's just at a bank branch, just for like their daily storage, not financial, just like daily storage. Like, oh, I need to download Microsoft Word, so it's in this local share, but it's not like cloud-based. And that's vulnerable. Is that going to be the number one risk for the entire international banking organization? Probably not. Now, let's say some financial records are at risk. There's a vulnerability on the Linux server that holds our financial records, or the NAS storage, the storage area network. It's NetApp, it's Dell EMC that's doing asynchronous, to the cloud. Why can't I think of the word? But it's like asynchronous duplication to the cloud. And we're like, okay, look, if this on-prem storage area network gets exploited, you know, we're done. We're cooked. We're going to be in the news. It's a data breach. We lose trust of our banking customers. So let's take a look at this. So let's say this is our local storage share right here, right? And it has a CVSS of 9.2. And then this is the financial records. Which one do we choose here? So this is the financial records, right? And it's a low possibility, but it's something super critical that we need protected at all times. I may say, hey, cyber team, go patch this before this, even though it has a higher score. Now, why? Because this may be a nothing. You know, this may not even be part of, well, it is part of our attack service, but it's such a small thing, right? That we may say, do this first, and then we get to this. Now, it all depends on the organization, but how you prioritize, you need to either look at your frameworks, your standards, your policies, and look at your risk appetite and tolerance of the organization. So an easy way, right? All things equal. Let's look at this, right? All things equal. This one's easy. So we have an IoT cloud backup. So we have IoT devices in our enterprise, and it's like your thermostat, whatever, right? And then we have our production e-commerce server. That's another great scenario where we say, this is the production e-commerce server. This is how we make our money. Are we going to take this down right away to patch this? If it was up to me, I would say, do this in a testing environment. At 2 a.m. when we have barely any customer interaction, you got 2 hours to patch this. And if not, we roll back with the severity, right? And then we'll get to this, right? We'll get to the IoT. But some organizations, let me tell you, that I've seen, they'll just move on from this. They'll know it's on there, but they'll be like, we don't know. We can't find a good ASI time. We don't want to lose money. It's crazy. Okay, risk remediation, risk validation, and third-party risk. So once risks are assessed and prioritized, organizations decide how to address them. This process is known as risk treatment or remediation. Risk may be mitigated by implementing controls, transferred through insurance or contracts, accepted if they fall within tolerance, or avoided by eliminating risk activities. So these are terms that aren't defined in SecurityX, but they are in the lower level certs. This is like risk transference. That's where we send it to an insurance policy, right? We have risk acceptance. That's where we say, we're fine with this risk, and we have risk mitigation. That's where we completely get rid of it. Where we say, no, patch it. Patch it, I don't want this risk. Those terms kind of define what this is talking about, but they're not defined in our SecurityX exam objectives directly. Risk validation. This ensures that remediation efforts actually reduce risk as intended. So validation includes control testing, audits, reassessments, and review of incident data. I always think of this as Patch Tuesday, right? So like, we need to upgrade our Windows environments because we know there's vulnerabilities. Cool. So a new patch comes out that's going to remediate some of these vulnerabilities. Do we just go update? We say, hey, every user, we don't care, go update. We need to remediate this patch. No. What we're going to do is probably put it in a sandbox testing environment, apply the patch, look at it, something that mirrors production, and then we're going to say, okay, test it now. We need to do some quality control. All of our third-party apps work? Great. Now let's apply this on production, and we just say we're good. JK. We apply it on production, and we say, we know in the testing environment it worked, but now we put in our authorized service interruption or advanced service interruption, and we say, let's apply this patch that we know didn't break nothing in testing, apply it, scan it, vulnerability gone, but now we quality control again. And this isn't just maybe on cybersecurity engineers, this is a team effort, but it's something that we're directly involved in as a cybersecurity team. Okay, and then third parties. So anytime we're introducing a new library, maybe a software development kit, an API to like a B2B or a B2G or a B2C connection through another identity provider that we might be integrating to or federating, there's a risk. We must assess these third-party frameworks, libraries, software development kits, whatever we're integrating into our enterprise. We must make sure that that library has some sort of paperwork or policies on it, or we just accept the risk and say, we'll bring it in and then we'll kind of do our own assessment. Oops, sorry. Okay, supply chain / vendor risk. And then something new here that I had, honestly, be honest with you, I had to learn before I taught you is cell processor risk. We'll go over it. Especially in the age of AI, it definitely makes sense of all these OEM hardware providers building chips, new chip plant in Phoenix. We'll get to it. So supply chain risk occurs when products or services are compromised before they reach the organization. This could be software. This could be hardware. It could be firmware. It could be at any stage when we're procuring. Where are we procuring from? And at any point in that chain, do we leave ourselves vulnerable? Now, with the government, if we're not buying COTS, we have to buy hardware, especially like IT hardware, from specific suppliers, right? We have a NIAP list. We have hardware certification lists. If we're doing something like CSFC, only certain vendors can be used for components of that architecture. So we do this all the time. Now, if you're just a managed service provider and you got to provide a customer with 50 Dells, you go straight to Dell, you may think we're good, but you have to go through a VAR for that. You probably don't go through Dell. So you go through like Worldwide Technologies, whatever authorized reseller there is, and you say, okay, we trust them. But you see how the link's already building. So then maybe they say, hey, Dell can't provide 50, they can provide 40, and we'll go out to the market. We'll try to go to Micro Center or some other third party to bring in another chain in that supply chain that could be a risk. So you just got to know where things are coming from. And in the government, we already have kind of those systems in place. Okay, then vendor risk, just kind of talked about that, where they're using a cloud platform, an internet service provider, a software development kit, APIs to an identity provider, SaaS vendors. We want to make sure that these vendors, the way they do security aligns with our organizational policies. So we want some oversight. Okay, sub-processor risk. So this risk arises when vendors rely on additional third parties to process data or deliver services. So these relationships are often less visible but equally important. Kind of what I just described in that supply chain, but now it defines it, right? So like I was saying, you know, with chips and stuff and like RAM and GPU coming out, you say, yeah, it's all from NVIDIA, right? But you gotta look at where these plants are coming from. Where you may be buying this hardware that's about to become kind of like not really available. You're going to start seeing a lot of VARs, MSPs, jacking up the prices because they can't get it direct from OEM. So they're going, you know, outside, resellers, whatever. So it's going to become a greater risk as we enter this age of like this AI bubble or whatever you want to call it, age of AI. And now our supplies are running low because there's such a high demand, right? Okay, quiz time. Let's do it. All right, so we're at domain 1.2.1. Okay, so question 1. A security team... let me bring up the chat in case you guys are answering. Okay. A security team ranks identified risk as low, medium, high, or critical based on expert judgment, business context, and threat trends. The team does not assign specific financial values to the risk. Which type of risk analysis is the organization performing? So let's just rule out a couple things, right? It's not B or D. That's not risk analysis, which this is what we're doing. We're identifying risk. So now we have to choose between quantitative and qualitative. Quantitative is numerical. It's metrics. So yeah, Masood, you're right. It is qualitative risk analysis, C. Okay, moving on. Okay, question 2. An organization conducts a tabletop exercise that examines the effects of a ransomware attack encrypting all production systems during peak business hours. That's no good, right? During peak business hours, they know what they're doing. The exercise focuses on lost revenue, regulatory penalties, reputational damage, and operational downtime. Which risk management activity is the organization primarily performing? So we want to see how much we lose, essentially. What's the impact? So I'm going to go with B. Impact analysis using extreme but plausible scenarios. You really didn't even need the extreme but plausible scenarios. I know it's on the exam objective, so good. We're going over it, but it's the impact of something. And we're doing a tabletop exercise to see. I think I used that term too, tabletop, so cool. Next question. So question 3. An organization requires its cloud service provider to disclose all third parties that process customer data and mandates that those parties meet the same security requirements as the primary vendor. Which risk management concern is the organization addressing? Cloud service provider. Third parties, right? That's the key one. Yeah, so I saw you change your answer, Masood. Yeah. Off rip, you think vendor risk, right? And this is like, I try to word these like I think CompTIA would, and it's like you miss that little third parties, you might get it wrong, right? Right, it's vendor risk, but more specifically, it's sub-processor risk. Because those third parties. All right, let's go. 100%. Good job, guys. Okay. Let's go back to domain 1.2.2. 1 second. Okay, so domain 1.2.2. We'll go over this and we'll take another break. Sorry, my voice just, even though I love teaching, I don't know, I guess I wasn't born with the voice to just teach like some of these lecturers you see go for 8 hours or some of our competitors. So sorry if I take too many breaks for you guys. Okay, let me bring up my other monitor. Where'd it go? There we go. Okay, so we're still going over domain 1.2. Given a set of organizational security requirements, perform risk management activities. Now we're going to go over availability and confidentiality risk considerations. So here's what we're going to be going over in the red. Okay, so first we're going to talk about business continuity and disaster recovery. In other like cybersecurity certs, you'll dive into this. You'll go over like the recovery point objectives, recovery time objectives, hot, warm, cold sites, a BCP. But here we just kind of do high level. So business continuity focuses on maintaining critical business operations during a disruptive event. So something happens, anything, natural disaster, exploitation, insider threat, whatever the case may be. So how do we maintain business operations? Something happens, how do we maintain the business? Do we have a COOP site? What does it stand for? Continuity of operations site. So this does not necessarily mean systems are fully functional. Instead, the goal is to ensure the most important services continue to operate. So in the military, right, like Green Suitor, we always looked at this like if we're in a denied environment, what are our critical C2 apps? And you probably still look at it this way, like with Army's Next Gen C2, it's still the same thing. Like we have critical apps that they need at the edge now doing compute, whatever, okay? But that's what it is, business continuity. In the worst cases of an event, how do we keep the essential services alive for customers or employees or users? Now, disaster recovery is, okay, something happened. Cool. Disaster happened, whether it's natural, we got exploited, a vulnerability got exploited, whatever the case may be. Now, how do we recover? So that's where those RTO and RPOs come in. So what's the timeline to recovery? What's our recovery point objective where, hey, we do synchronous backups every 15 minutes or asynchronous every 15 minutes. If I don't get this back up under that 15-minute mark, I lose data from that users that have maybe saving things to a shared drive, whatever the case may be. So we have two things that can help define a disaster recovery for us. That's recovery time objective and recovery point objective. And from a risk management perspective, these plans ensure the organization understands how much downtime and data loss it can tolerate. So it's kind of like, hey, if we don't recover in 2 hours, we will start losing profit, right? That's kind of part of our RTO analysis. Okay, testing availability control. So how do we know what's going to work? How do we know our disaster recovery is going to work if we never have a disaster? Because a lot of times, cybersecurity focused and forward organizations and industries, they'll plan for the worst case scenario. They do all this planning. They make something high availability. They get load balancers. They're very redundant, different availability zones, synchronous backups, RAID, the best RAID 10, 50, 60 for their on-prem. They have multi-cloud environments, which no one really does, but let's just say they do, right? For some things, databases, redundant databases, they do it all. But how do we test it? So how do they know it works? Just because they did it, you need to test it. So we need to test our availability controls, whether that's a tabletop where we just gather around and talk it through, whiteboard it out, and we say, this should happen, and your roles and responsibilities are this. Then we have like an actual simulation test where maybe we put the availability controls that we implement in production, we put it in a testing environment and we say, okay, risk. Now let's do some fuzzy. Let's do some dynamic analysis. Let's actually exploit this website. Let's actually exploit and see how we recover. So testing validates the business continuity plans, disaster recovery procedures, and failover mechanisms functions as expected. There's another one. I can't remember the exact name, but it's like live testing where essentially you do it on production. You put in like a service interruption, an authorized service interruption, and then you actually test live. We did this downrange testing like SATCOM, right? So we had our big disassociate fiber ring, whatever, 200, 300, 400 megs, whatever it was at the time, maybe probably not that high. And we're like, okay, we're going to fail over. We're going to fail over to our FDMA shot, and let's make sure our critical services stay online. So there's live testing as well too. Okay, connected backup. So how do we back up? So again, SecurityX, even though it's technical, such a high level. This one's like, when usually we go over backups, we go over like incremental, differential, and full backups. We go over synchronous and asynchronous replication. And then we, talk about persistence, last known good configurations. But here it's just like connected, not connected. So let's go over it. Connected backup is you are connected. So you're connected via network, an IP address, a subnet, whatever the case may be. You have a direct connection. And more than likely during a connected backup, you're doing synchronous replication, where if I save something in Azure West, boom, 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 it goes over to Azure East right away. Think of this like storage accounts, whatever the case may be. So the primary advantage of connected backups is speed. So if this goes down, I'm directly connected. My users are linked in here and they're linked in here. So quick, faster recovery, right? So you have probably a good RTO and good RPO. So disconnected backups. Now, because I haven't worked in every industry in IT, I'm assuming in OT environments you may do this. You do this at a light scale where, we have a hard drive we use where we download all our iOSs and it's on the hard drive, and then we connect those iOSs to our shared drive. And if our shared drive goes down, we still have everything on that little external 2 terabyte. So I guess, I do this too. When I think of like enterprise though, like user data, like everything I save to a shared drive, everything in my user database, my production database, I'm like, do I put that on a disconnected backup? I don't know what industry would do that, but that's essentially what it is. Just putting data on a removable media, and then you have it. And this is obviously very asynchronous replication because you got to plug that in, right? Transfer and then disconnect it. That's the whole point, it's a disconnected backup that you may have sitting on your desk. But why is it safe? Because if you maintain like positive control of it, you always have that with you. It may never be tampered with. Okay, confidentiality, risk considerations, and then we're going to go over our data leak. So confidentiality refers to protecting information from unauthorized access or disclosure. So when confidentiality is lost, sensitive data may be exposed to individuals or systems that should not have access to it. So confidentiality risk are serious because data exposure can lead to regulatory penalties, legal action, reputational damage, and long-term loss of trust. Kind of everything we've been talking about when I say data breach, right? It's going to get into some definitions here, data leak. But essentially, confidentiality is where we've been entrusted by some sort of customer, our employees, our business partners to protect their data, protect their PII, maybe their PHI, their financial records, whatever the case may be. And we may be told by our government that you must protect the data. It's not a if you should add these controls, it's you must have these controls. When I say that, I'm thinking GDPR, General Data Protection Rights in the EU. So we need to look at that confidentiality and see where's the risk in that. And what is the risk? What actually happens? What do we call that? So data leak. So a data leak occurs when sensitive information is exposed outside of authorized boundaries. So this could be misconfiguration, insider activity, malware, or external attacks. Think of falling victim to a phishing attack. You don't even know it, download something in the background, and the whole point is to do lateral movement and then data exfiltration. So we protect data exfiltration with DLP and continuous monitoring in line and maybe in a monitoring state. So that's a data leak, just things getting out. And it's not a full-on data breach because, again, this may just be like an insider taking something and taking it to Dropbox, and that's what we're going to call a data leak in the SecurityX exam. A full-on data breach. So not all data carries the same risk. So sensitive data includes PII, financial records, everything I just talked about. So this is saying breaches are specific to that privileged, sensitive, or elevated data. So, okay, that's a good differentiation that I probably wasn't making here. So a data leak, according to the CompTIA SecurityX, is something that still gets outside the organization. It's not authorized. It maybe happen malicious, maybe not malicious, but it's not that sensitive data that we can categorize, okay? So data breach, this is saying in the CompTIA SecurityX that this is something we can categorize. So this is PII, PHI that is being exfiltrated or unauthorized being moved, okay? So this is sensitive data. So it's a good differentiation. Just wanted to make that clear for our SecurityX exam. Okay, incident response testing for confidentiality events. So we need to be prepared, right? We need to do testing and how we do incident response, but we need to make sure that we actually have incident response plans in place. So incident response plans for data breaches must be tested to ensure they work in practice. And incident response testing evaluates how effectively the organization can detect, investigate, contain, and recover from these incidences. Blue team, red team. So this is, I may hire someone externally to say, hey, we're going to do a white box test. I'm going to give you the information you need. Exfiltrate. Exploit and exfiltrate on these days. Now, again, this is like, it's all organizational based, because if you're hiring a penetration testing team to do this kind of testing to see how well your SOC reacts, you don't want to do it on like production environments where your customers are relying on it. So you want to be very careful with this, but you need to test it. You need to make sure your incident response plan is good. And a lot of times it just comes down to maybe just a formal test saying, hey guys, don't do anything differently, which employees are, you can say that, but we're going to go to our testing environment. We're going to have a breach. I want to see how you would respond to it. That's better than nothing, even if you can't do that live simulation test. And the point, just you want to make sure that your incident response plan is good, that you're every single step, everyone knows what they're doing and you have the right things in place. Okay, reporting requirements. So there may be some reporting requirements that are part of data governance. What I mean by that is GDPR, a great one that says you must report this. There's other like things in America, like NIST has its own reporting mechanism. So like in our environments in the military, right? If a hard drive gets plugged in and you know about it as a cybersecurity engineer, you must report it. And there's going to be policies and procedures on how to do that. Okay, encryption. Encryption as a confidentiality control, high level, right? So remember, this is a high level thing where we want confidentiality. So what's the most basic things we can do to hide our sensitive data is change that plain text sensitive data into ciphertext. When data is at rest, we encrypt it. We use a symmetric encryption algorithm like AES to do full disk encryption, or like PB, what is it? It's like PBCDK2. We'll get to it, okay? I'm sure we'll go over in a slide, but that's full disk encryption. BitLocker, basic thing that Windows does, full disk encryption for our data at rest. If you don't have that PIN or that passphrase, you're not getting access to the data on that hard drive. Data in transit. So if we're sending data, we have remote users. When we go over Zero Trust, we're going to go over this a lot more, but our environments are not this nice little perimeter anymore. We have SaaS applications and multiple cloud vendors. We have remote workers accessing the cloud, accessing our enterprise. And when they're transmitting our company's data to and from all these different points, we got to encrypt it. Some sort of encryption, whether that's TLS, whether that's IPsec, or whatever kind of VPN you may use. Cisco AnyConnect client, whatever it may be. All right, let's do a quiz. We'll do this quiz. I got to take a little break, guys. I don't want my voice completely going away. So we're going to go over domain 1.2.2. All right, taking a minute to load here. That's how you know we got a lot of good quizzes here. Okay, we'll go to our lessons. Domain 1.2.2. Let's do this quiz. Okay, so question 1. During a tabletop exercise, an organization discovers that multiple teams are unsure who has authority to notify regulators after a data breach involving customer personal information. Which confidentiality risk management activity would most effectively address this issue? So we don't know who to report to, which is the whole point of a tabletop exercise, to go over responsibilities and roles and what you're supposed to do, right? So this is pretty much testing how we would do incident response, right? Data breach. It's not encryption. It's not privileged access management. Yeah, this one, the answers made it easy. It's B, incident response testing. So that's something we can do in incident response testing. What I was telling you, maybe it doesn't have to be live on the, production environment, but we can go to our staging environment and do this. Or testing environment, whatever you may have in your organizations. Okay, question 2. An organization experiences a ransomware attack that encrypts its production servers and deletes all backups that are continuously accessible from the network. However, the organization is able to fully restore its data from backups that were stored offline and not connected to production environment, so they're disconnected. Which availability risk management concept best explains why the organization was able to recover? Disconnected, right? Offline, air-gapped. Something that isn't always online and doing synchronous replication. So yeah, we're going to go with C here. This quiz feels a little easier than the other ones. Okay, question 3. An organization encrypts all sensitive customer data stored in its databases. A threat actor later gains unauthorized access and exfiltrates the encrypted data, but the encryption keys remain secure. Okay, let me private key. From a confidentiality risk management perspective, what is the primary benefit of encryption in this scenario? So we encrypt our databases. Someone gains access, which doesn't mean they decrypted it. It's just they have access to the database. So maybe they connected off that SQL port and they're there and they're trying to do some SQL commands and they can't see anything. They need a password, they need a private key. So even though unauthorized access happened, because we encrypted, our data can't be, I'm not going to say breached, because if you have access, you could exfiltrate, it's still encrypted, but it's not, they can't see it. So data exposure, right? So it's not A, he already got access, or he or she already got access. It eliminates the need for incident reporting? No, encryption does not do that. It reduces the impact of the data exposure. Yeah, I think I'm going to go with C here. And I hope you guys understand why, because again, he or she already got access. So databases can be encrypted, it doesn't stop access. It has nothing to do with access controls. So somehow he or she got the username and password to that SQL database. Let's just say, for example, they're in there. But then they try to do a SQL command and they're like, I can't access any of the prod data, any of the employee data, whatever it is. I need an encryption key that I don't have, like a private key to decrypt. So we're going to go with C. All right, awesome, guys, 100%. Let's go ahead and take a 10-minute break. I need to grab some water, and then we will return. Okay, everyone, let's go ahead and continue. We're going to finish up our domain 1.2 lessons, going over integrity and privacy risk, crisis management, and breach response. Okay, so in the red is what we're going to go over. Okay, so integrity as a risk management concern. So integrity refers to the accuracy, completeness, and trustworthiness of data and systems. This is when you go online, you see a message digest that says, download this checksum. This is adding a digital signature to your email, and that gives you non-repudiation and integrity and uses asymmetric encryption to verify that you are the accurate sender. So that is what integrity is. So when integrity is compromised, information may be altered, deleted, or just fabricated without the actual authorization. So when we do have integrity, we know that it hasn't been altered. It is that data is from who we think it's actually from. But with integrity failures, they may go unnoticed while still causing serious damage. So decisions based on incorrect data can lead to financial loss, safety hazards, violations, and loss of trust. Remote journaling. So this is a method used to protect data integrity by maintaining a continuous or near continuous record of system transactions at a separate location. So maybe saying, remote journaling, isn't this just like log backups? Well, it's a little bit more complex than that. It's kind of something we don't see. Now I want to say we don't see a lot of. Sometimes it's implemented. And this is like synchronous replication of any transaction happening on a server. I say transaction as just a high level transaction, whatever data is being transacted against. So here's kind of how it works. So each change made to the primary system is recorded and transmitted to a remote system in real time or near real time. If the primary system is compromised by hardware failure or by anything, we have a list here: malicious tampering, ransomware, inside activity, whatever the case may be, exploited, tampered with, the organization can reconstruct the correct data state using the journaled records. Remote journaling, it's records, it's synchronous replication. But when we use that term synchronous replication, it's kind of more like storage. So remote journaling just says anything, a source server to a target server based on, and we record all the transactions. So it can also introduce new risk. The journal itself becomes a high value target because if it's near real-time replication, then it's just as good. It's just as good to attack and exploit because everything the source server is going to send to me. So if I'm exploited that and I'm doing data exfiltration on that target server, that remote journal server, that's just as good for me as an attacker. So what we mean by that is protect them the same way. Harden them and assess them, monitor them in the same exact way. Hashing. This is basic. How do we verify integrity? We take a hash. So a hash gives you a unique message digest or checksum from your data or your data input, and we can use that digest to verify. So how can we do this? So imagine you're going to download an application like Notepad++. You download Notepad++, and then on that website, it gives you a checksum library. It's just a text file that says, hey, if you're installing this executable, if you run a SHA-256 hash algorithm against it, you will get this digest. So you can check that locally now. So you download it from their server, you got their file with all the checksums, and you go to your command prompt here, and you say get file hash signed PDF algorithm SHA-256. You copy that hash, and this is something local. So this is on my documents. And you say, okay, now let me compare that hash to what the website is saying the hash should be. And if it's the exact same, boom, nothing was tampered. But if it's changed, if it's different than what's on the website, what you got here locally, we got a problem. Possibly could have been altered, right? Interference. So interference refers to actions that disrupt or manipulate systems. Another word that CompTIA SecurityX is using at a high level. This is man in the middle. This is jamming. This is EMI interference. This is anything where I sit in line. I sit in line of data, whatever that data may be, whether it's Ethernet, fiber, Wi-Fi. And I say that, thinking at a high level now, but anything that I can affect, anything I can interfere with, okay? So interference can cause systems to behave unpredictably, leading to corrupted transaction, incomplete data, or inconsistent system states. This is supposed to be like side loading. You could like side load like RAM and the memory cycles and stuff like that, using like something physical, like EMI interference. Not EMI for RAM. I can't think of it right now, but essentially you do some side loading attacks. Anti-tampering. So anti-tampering controls are designed to prevent, detect, or respond to unauthorized modifications of systems, software, or hardware. Something like it's like a honeypot file can help us with anti-tampering. We have something like FIPS. FIPS is kind of, well, essentially anti-tampering lets us know if someone tried to mess with like firmware. There's a lot of anti-tampering firmware. In the physical world, there's like tamper-evident seals, secure boot processes. That's where we take TPMs, trusted platform module chips, and we say, hey, when we first boot up this system, we're going to take a hash of our BIOS check. So we're going to take a hash of all of our OEM on our motherboard, and this is how it boots up. And we're going to store that hash in a TPM. And now every time we reboot, we're going to take another hash, and we're going to compare it to that original one that's stored in the TPM. And if it matches, boom, boot up. But if it doesn't, we're not going to allow that boot to happen. So that's an example of anti-tampering. So anti-tampering controls reduce the likelihood that attackers can modify systems without detection. FIM, that's what it's called, file integrity monitoring. FIM's another way it's kind of an anti-tampering control. If you think about it as a protocol or application that allows us to know if someone tried to get into a file they shouldn't have and tamper with it. Data subject rights. So data subject rights give individuals control over how their personal data is collected, used, stored, and shared. This whole slide is built off the GDPR. If it wasn't for the EU, we wouldn't have this slide. So this is all about your personal data rights when that data gets sent to the organization, the company you're buying from, you're working for. The GDPR says, no, that's your data. They think it's not just the company that owns it. Yes, they do. They process it. They control it. They own it. But you have rights to it. You have a right to delete it. You have a right to be forgotten. That is data subject rights. And if you're in the EU, you must abide by these GDPR standards. I put California also has a state one in there. It gets real fishy, though, because, again, in America, yeah, we have state laws, but if there's no federal data protection rights, do you really have to follow it if you're running a data center in California? The state says yes, so the state could fine you, but the U.S. federal government won't fine you. So anyways. Okay, data sovereignty. So this is just a high-level principle that we learn in every cybersecurity course that says, depending on where you're at geographically, you have different rules and regulations that you must abide by. That's data sovereignty. So the different regulations per jurisdiction. That could be at a local, state, national, international level. Biometrics. So I didn't skip one, right? Okay, so biometrics, this is just really deals with like authentication, and there's another way for us to protect our access and access controls and our authentication processes. So biometrics is anything unique to you. It's something that you are. When we look at like the different factors of multi-factor authentication, something you know, something you have, something you are. The something you are is the biometrics. It's your biology. That's fingerprint, iris scans, face scans. Crisis management. So crisis management refers to the structured approach used to prepare for, respond to, and recover from high-impact security events. This is part of our communication report. This is part of our PR planning. This is another part of incident response. That isn't just the technical part of, containment, isolation, and recovery, eradication, and all that. Crisis management is from a risk management perspective. How do we go and communicate to all the different stakeholders in our organization and ensure there's no miscommunication? How do we manage that? And we have a lot of tools: communications report, our actual incident response plan, our business communications plan, so many things, right, that we can help us, and there are the tools for our crisis management. Breach response. So breach response is the set of actions taken after unauthorized access to systems or data is detected. It focuses on containment, investigation, remediation, and communication. So breach response isn't just the incident response plan. It is, again, breach response also could be wrapped up into the crisis management. Breach response is how does everyone that has a role post-incident or during incident, what do they do and how do they do it? Remember I told you CompTIA likes to be a little redundant. You're like, breach response is part of incident response, which is part of crisis management. Yes, they all tie in together, but sometimes we have to get real granular in how we define them for our certification exams. So breach response is not just about fixing what went wrong. It is about learning from the incident to reduce future risk. Post-incident analysis informs improvements to controls, policies, and training, which again, in incident response, there's a section in there called lessons learned phase. But anyways, this could be a part of that. Okay, let's go ahead and do our quiz. Again, yes, it may feel a little redundant sometimes, but that every I train a lot of CompTIA cybersecurity certs. Besides like pen test, they all get a little redundant sometimes, and they all kind of tie in together as you'll start to notice a lot of these different, policies, procedures, and things that we are learning together. Okay, bring up my other screen. Question 1, and we're in domain 1.2.3 quiz. A multinational organization stores customer data in a cloud environment. The data is encrypted, access controlled, and regularly audited. However, regulators determine the organization is in violation of privacy law because the data is stored in a foreign jurisdiction. Which privacy risk consideration is most directly involved? So we're talking about jurisdiction here. Let me bring up the chat. Yeah, you're right, Jeremy. It's going to be C. So keywords here, jurisdiction. So this is saying we have customer data in a cloud environment. Maybe we're processing EU customers, but our cloud environment is Azure West, US West. So that could not be allowed according to the GDPR. So that's looking at data sovereignty laws, where we are geographically located. So yep, C is correct. Question 2. An organization uses hashing to protect the integrity of critical system files. During a security audit, it is discovered that an attacker was able to modify both the file and its stored hash value. Which integrity risk does this situation most clearly demonstrate? So we have a critical system file, whatever that is. Maybe it's a Etsy host file, some database file, whatever. And during a security audit, an attacker is able to modify both the file and its stored hash value. So we're affecting the way that we can verify integrity by messing up the stored hash value, by probably messing with the original data, whatever that original data is. So which integrity risk does the situation most clearly demonstrate? Let's see. Hashing prevents unauthorized file access, but not file modification. No, hashing has nothing to do with file access. That's access controls. Hashing doesn't encrypt, doesn't convert plain text to ciphertext. It just creates a message digest that verifies integrity. So hashing detects changes only when hash values are stored securely. That is true if our hash values get compromised. We can't really rely on it. It's not good integrity. It does not encrypt. And data in motion is not even a thing. It's called data in use. So we're going to go with B here. Hashing detects changes only when hash values are stored securely. Question 3. Following a data breach, an organization quickly isolates affected systems, preserves forensic evidence, notifies required parties, and conducts a post-incident review to improve future controls. Which risk management activity is being demonstrated? So we isolate affected systems. We preserve the forensics evidence, notified required parties, and conduct post-incident. Post-incident. Yeah, Jeremy, you're right. To me, this is incident response. It's CompTIA, whatever. I'm not going to fight it. But let's do some deductive reasoning. So they isolate, they preserve forensic evidence, which is good. We may have a legal hold on that. That's our digital forensics part. We had good communication with our stakeholders. And then post-incident is that key one, right? Because crisis management, notify required parties, that would fit crisis management. It's not anti-tampering remote journaling because this is a breach happened. So the only good answer here is D. But if I had to say what was the key word there, it's post-incident. Remember, breach response, like I told you, an incident response is part of that lessons learned phase. It's how we improve from there. So that's part of it. So yeah, we're going to go D, breach response. All right, awesome. We got 100%. Okay, moving on. So now let's go on to domain 1.3. So we're going at a decent pace, guys. Usually I'm super long-winded, but we're doing good. Better than I thought I'd do today. All right. So now we're going to go over domain 1.3. Explain how compliance affects... Sorry, hold on. Just Explain how compliance affects information security strategies. And we're going to go over industry-specific compliance and industry standards. Oh, just jump right into my red text objectives. Okay, so here's our objectives that we're going to go over in domain 1.3. So in this section, we're going to go over awareness of industry-specific compliance and industry standards. Which, again, remember, it's kind of been redundant. I've been talking about like HIPAA, healthcare, finance industry, but now we're going to actually talk about it. We're going to put it on a slide. So let's go over it. So industry-specific compliance requirements. Compliance requirements vary significantly by industry based because different industries handle different types of data and face different risks. So I don't want to just read the bullet points for you. This is something obvious, right? We work in the DoD, but other people work in healthcare. Other people work in OT environments. Other people work in financial environments, electrical environments, whatever the environment may be. We're going to have different frameworks. We're going to have different compliance, right? Industry-specific compliances for that. It's kind of obvious, but now we want to just break it down. So healthcare. We're worried about PHI, Protected Health Information. The compliance requirement there is HIPAA. HIPAA defines that. I'm going to move on from it. This is pretty simple. I don't believe in the SecurityX exam they're going to ask you, pick 2 of the following answers that's part of protected health information. But if they do, I got a nice little diagram for you provided by Data Brackets. And we have the links to all these different websites that we use their images from. I want to give them credit. But yeah, that's healthcare's HIPAA, PHI. That's really what we need to know at a high level. Finance. So this has nothing to do with the finance industry. This is just my favorite finance guy on YouTube. It's just fun, right? But the big one, okay, back to SecurityX. The big one is PCI. PCI compliance is really the big compliance requirement in financial industries for the banks, but even for you as maybe a business owner that has point of sale machines, restaurant owner, retail, whatever the case may be. So the financial industry includes banks, credit unions, investment firms, payment processors, which again, that could be you, but it's a little easier nowadays because again, we can just like go to Stripe. We can get these commerce-based companies that give you point of sale machines and they kind of handle it all. And insurance companies. Insurance companies be part of the financial industry because transacting money. PCI DSS is what we need to know. That's the compliance requirement for finance. And then we also have third-party audits. So like SOC 2 audits can come in and audit your financial industries. And that's something that they might want, but it's not necessarily like a government requirement. PCI too, just to clarify that too, it is a compliance requirement, but it's actually not something that was like voted on by Congress or something that the federal government enacted. Maybe it is now, but the original history of it was that it was actually the credit card networks. So it's actually like Visa, Discover Card, Amex coming together and saying, hey, we're going to create this requirement and everyone that wants to use our network, our Visa network, Discover Card, MasterCard, Amex network needs to be in compliance with this, so we won't let them do transactions in our network. So it was built by industry actually. Okay, and government. So government compliance, there's so many. And maybe there's a lot for these other industries that I just don't know because I'm not in it, but we have FedRAMP. That's the compliance requirement for bringing SaaS cloud-based applications into the DoD. We have NIST, CSF, and RMF, the NIST standards. We have Type 1 encryptors in the government. We have our ATOs that are our authority to operate. We have our different mandatory access controls that are defined by NIST that we must have clearance for in the government. So there's a lot of strict compliance in the government. The big ones you need to know about for the exam, NIST is pretty much the big one. FedRAMP, if you want to do any cloud-based work in the government. And what I mean by that is sell your cloud product to the government. Those are the 2 big ones that I see a lot when it comes to like government regulation. Utilities and critical infrastructure. So they're defining it as utilities and critical infrastructure, but this is kind of the OT environments, our operational technologies. So these include power grids, water treatment facilities, transportation systems, telecommunication providers. And a lot of times this is a big OT environment that isn't a one-size-fits-all. And a lot of the compliance for this is going to be like government-regulated compliance. And there's a lot of good ISO, International Standards Organization frameworks to help you become in compliance for your certain OT infrastructures. Okay, so PCI DSS, like we've already talked about. I'm just going to, stay on this slide a little bit so you can actually read. So the payment card industry data security standard applies to any organization that stores, processes, or transmits payment card data. I think that's all we need to look at there. Right here, so big things about PCI is always network segmentation. It's always encryption on data in transit. It's always about access controls. And also something I want to point out, detailed logs as well. Logs, because you want to be able to see, if someone's fraudulent at these organizations or if there is a data breach, PCI says, hey, we need to have some sort of logging going on these point-of-sale machines that are processing. ISO 2700. So this series focuses on information security management systems rather than prescriptive technical controls. So let's kind of break that down, right? A lot of word garbage there. The ISO 2701 is really the big one that a lot of people want to be in compliance with. So it requires organizations to identify information assets, assess risk, and select controls based on documented risk analysis. So it says it focuses on information security management systems rather than prescriptive technical controls. And what that means is the ISO 2700 isn't going to tell you, the syntax for hardening or doing ACLs. What it's going to tell you is, hey, the 2701 is going to say, here's how you should assess risk and select the best controls. So that control being high level, you should use a role-based access control to protect this. But it's not going to tell you how to implement it in Enter ID versus Active Directory or things like that. Now, a lot of these frameworks, these industry standards won't. Where PCI may be a little bit more technical, where it says, no, you need VLAN segmentation for this point-of-sale machine at the network. You need this level of encryption for us. Where the ISO may say, you need encryption. You need RBAC. Did I skip one? Okay. DMA, Digital Markets Act, something I had to learn actually when creating this course. So the Digital Markets Act focuses on large digital platforms that act as market gatekeepers. It's not a traditional security framework. It has significant implications for information security. DMA compliance emphasizes transparency, accountability, and responsible data handling practices. Okay, quick one there. All right, let's go ahead and do our quiz. This quiz. And we're at domain 1.3.1. Let me bring up the chat for you guys. Okay, question 1. Which of the following best explains how the payment card industry data security standard influences an organization's information security strategy? So A, it provides general security recommendations without technical requirements. Probably no on that one. It does require technical requirements. B, it focuses primarily on employee security awareness training. No, I'm sure there's part of that in it. I've never read it fully, but I'm sure there's part. C, it mandates specific technical and administrative controls for protecting cardholder data. Yeah, we're going to go with C, right? Obviously, D is not true full. It's not only, but it does apply to financial institutions and banks, but that only keyword messes that one up for us. So we're going to go with C. It mandates specific technical and administrative controls for protecting cardholder data. Yeah, good job, guys. Got that one correct. C. Okay, question 2. An organization provides both healthcare services and financial payment processing. Why must its information security strategy address industry-specific compliance requirements instead of applying a single uniform security model across all systems? Because it's both. And we talked about this with healthcare providers. If you have a doctor's office, maybe that does plastic surgery, you're doing transactions, right? You're part of that financial industry because you're transacting large amounts of money. Even a hospital. We did an ER stay with my daughters when I didn't have healthcare coverage because I was in between jobs. It's $2,000. It was just ridiculous sometimes, but sorry, this isn't a political thing. It's just crazy. But yeah, a lot of times healthcare does do both. So we're going to go with B here because industry regulations impose different security, privacy, and accountability requirements. Here's the explanation. Question 3. Let's see if we get an 100% here, guys. Why do standards such as the ISO or /IEC 2700 series emphasize a risk-based approach instead of prescribing specific technical security controls. So again, this is supposed to just be a high-level thing that's like, you should do encryption, you should do least privilege, you should do network segmentation, you should do micro-segmentation. As I've skimmed through this ISO, I wouldn't say I'm an expert on it, but that's kind of how it reads to me. And it kind of understands that even if you're in the same industry, do you think you're going to be doing the same exact thing as your competitors? You may have a disruptive technology, and maybe my standard fits you differently. So we're going to go with A here because organizations face different risks, technologies, and business objectives. And see how it says organizations, not industries. Awesome. There we go. Another 100%. All right. Let me take a little drink of water here, guys, and then we'll go over domain 1.3.2 and then take another little break. Okay. Domain 1.3.2, explain how compliance affects information security strategies, and we're going to go over security and reporting frameworks and audits versus assessments versus certifications. Okay, then we're going to be going everything in the red. So slide 1, security and reporting frameworks overview. So security reporting frameworks provide structured guidance for designing, implementing, and managing information security programs. These frameworks define control objectives, security principles, and governance expectations that help organizations consistently manage risk. Okay, so I don't always like just reading off the bullet points, but we just got to kind of be on the same sheet of music. So we're going to go over different kind of terminologies in these frameworks and in security. So benchmarks. So this is a CIS. What is it? The computer something security. I forget what the CIS actually stands for. It's another popular compliance or framework that is used in the cybersecurity industry. It'll come up on a slide. But anyways, what is a benchmark? So benchmarks are detailed, prescriptive standards that define secure configurations for systems, applications, and devices. So unlike a framework, which I always say is, it's high level. It's like you must do data in transit encryption using the secure cipher suites that are available to you. It's like, okay, so which one? A secure one based off your organizational risk. It's like, okay, thanks. But a benchmark is like, no. We want to see this happen. We want to see a golden baseline that actually enforces least privilege, that actually enforces RBAC, that actually enforces the minimum level of encryption at 128-bit key length for symmetric encryption, something like that. So that's like an actual benchmark. And this is going to be derived from organizational policy and frameworks, but it's something that you're going to put on there. Here's a benchmark we must hit. I think of STIGs like this, even though it's called guidelines, and we can POAM and say not applicable in all our STIGs, so it's not exactly one for one, but I think of that as a benchmark. We're like, hey, all of our category 1 STIGs, we need to fix, period, and that's our benchmark, right? That's kind of what I think of it. So in compliance-driven environments, benchmarks serve as evidence of proper system hardening. And then here's a, hold on, I need to click in that web browser so I can go here. Just an example from CIS. Center for Internet Security, that's what it was. Center for Internet Security of their benchmarks. So like how to, it's like STIGs, it's like what we have, but except this is not specifically the DoD industry, how they harden and their benchmarks for hardening. Foundational best practices. Moving around a lot. So foundational best practices are long-established security principles that apply across industries, technologies, and regulatory environments. So this is like, we work in the DoD. So a lot of my specialties in the DoD. I can't walk into a banking industry and know the compliance and how they harden in their best standards. I know when I harden my RHEL server, I use SCAP, OpenSCAP, and the protocol I use is STIG. Even though I see that I could do the PCI DSS hardening, I use STIG. That's what I'm used to. I know how to harden. I know the best practices fundamentally, but I can't walk into a bank and know, oh yeah, you need this specific guideline. But since I have those best practices, it is easy to transfer skills that say, no matter if I'm at a retail store, at a corporate environment, if at a small business, if I'm working in the cloud, if I'm working in the DoD, healthcare, it really doesn't matter. We're always going to have TLS Our VPNs are always going to be IPsec protected. We're always going to have some form of least privilege. We're always going to have some sort of network segmentation. Our Wi-Fi is always going to be WPA3, the highest standard. There's going to be these fundamentals that are always there. Every organization is going to have a defense in depth approach. Every organization is going to have an AUP. I can go on and on and on. I don't need to keep going. And then because I know what frameworks may apply, I can kind of map to what my industry is. The knowledge I already have is going to be easy because in that framework, in that guideline, in that benchmark, it's going to tell me, in this industry, we do it like this. This is the compliance requirement. So you need to have that before you can dive into an industry. So foundational best practices. Okay, SOC 2. So system and organizational controls 2. I bet you ask a lot of cybersecurity professionals, they never memorize that acronym. They just know, fuck, I got a SOC 2 audit coming up. Commonly known as SOC 2 is a compliance framework developed by the American Institute of Certified Public Accountants. This is primarily focused on service organizations and how to protect customer data. So this is like the big retail chains. They get SOC 2 audits a lot. So SOC 2 influences security strategies by emphasizing governance, documentation, and accountability. And when you get an audit, it's just a long list of SOC 2 requirements, benchmarks, applications that they're seeing if you hit properly. So not only is like, oh yeah, we must have RBAC, but are you enforcing RBAC to our standards of what that auditor believes? So it may not even be like, oh, hey, you have a good security posture, you're doing good defense in depth, but we don't think it's enough to actually protect to our standards. And that's because you didn't do RBAC enough or something like that. So that is a SOC 2 audit. And this is something that a lot of organizations, they do. If they pass, they put their stamp on it, and they can prove to maybe a customer, maybe a vendor they're going to work with, a third party, B2B, stakeholders, shareholders, that, hey, we are compliant and we are security focused. And even if, we may have some pitfalls, because you don't need to pass an audit 100% to get that stamp, that, hey, we're security focused. You can trust us. Okay, NIST CSF. We talked about RMF a lot when talking risk, but NIST also has a cybersecurity framework, which is a risk-based framework designed to help organizations manage cybersecurity risk in a structured and flexible way. So NIST CSF includes a security strategy by encouraging organizations to view cybersecurity as an ongoing risk management process rather than a collection of tools. I say this a lot because like NIST, a lot of people get confused when like you look at zero trust architecture, cloud-based service models from the NIST perspective. It is something that's like continuous. It's not something that's like, oh, hey, buy Entra ID and Sentinel and you're in good CSF. No, it's a framework, right? It's an architecture. It kind of defines what you need in your environment without telling you use this vendor, or only this vendor does it. It's very generic. It's very general. And that's what's good about it because it can really apply anywhere, whether you have Palo Alto, Fortinet, a Juniper firewall, a Cisco firewall, a Sonic Wall firewall. You can look at NIST CSF and say, how should my firewalls be set up if it's like a next generation and I want to do IDS, IPS, and behavior analysis? And it will talk in very general terms. So, and it's outcome focused. So organizations can tailor implementation while still aligning with regulatory and industry expectations. So it's very flexible, and it's just a nice roadmap for you to start hardening and building your defense in depth approach and kind of getting towards that, that zero trust kind of architecture. Not to say that CSF is zero trust, but something that can help you in our, in our environments now that are everywhere, where we have data everywhere that's not just on-prem. Okay, then CIS. The Center for Internet Security provides practical, prioritized security guidance designed to reduce the most common impactful cybersecurity risks. So CIS strongly influences security strategies, providing clear, actionable steps that organizations can implement quickly. So guys, this is always, I feel like, a tough one for me to teach. It's like, hey, Johnny, so which one do I use? It's just up to your organization. Honestly, you know what it comes down to as working professionals? What that engineer's done. So if I'm in an organization that isn't like government, just say an organization, MSP, and they have a bunch of different customers, we're like, okay, how do we secure these customers? You may have a cybersecurity senior engineer in there, a fossil or something that says, I've done CIS for 20 years, so that's what we're going to go with. That's how I'm going to do my hardening and my cyber procedures. And that's what it is. They're all good frameworks that all define how to build baselines, how to harden. They just have different maybe areas that may prioritize more. So with CIS here, Here it reads, many organizations use sys controls as a baseline security standard or as evidence of due care during audits. Pretty much saying we followed these hardening capabilities from sys. Okay, CSA, Cloud Security Alliance. So the Cloud Security Alliance focuses on security challenges unique to cloud computing environments. And it is unique because in cloud computing, different than on-prem security, is we have a CSP that has responsibilities of its own depending on our service model. So CSA frameworks address governance, risk management, and shared responsibility, key thing that makes it different than these other frameworks in cloud deployments. So this is going over cloud control matrices, those, RACI matrices, and it has tools like the consensus assessments initiative questionnaire. It's a lot of words that can help us determine how we should best secure our cloud environments. And again, this is going to depend on the service model. If you're using infrastructure as a service, platform as a service, or software as a service, you protect in a lot of different ways because you may have a lot more, a lot less customer responsibility. External versus internal evaluations, high level. This is just saying, what's the big difference between these two, not getting into the nitty-gritty of what type of external, like a SOC 2 evaluation is. So external audits and assessments are conducted by independent parties and provide higher credibility with regulators, customers, and partners. You get a high level of trust because there's no conflicts of interest. They don't have an vested interest in passing or failing you. They just are going by a standard in a perfect world. Internal audits and assessments are conducted by the organization to evaluate readiness, identify weaknesses, and improve controls. So it's a good intention. We're probably going to follow the same SOC 2 standards that an auditor is going to come in, and we're going to try our best. But obviously, it's not going to be that stamp of trust and approval that we can show our customers that we did an internal audit versus a third party, which may look more trustworthy. Okay, quiz time. See, no, I need to... Okay. It's okay. I'll just copy this and you go to my other web browser. There we go. So now we're going to do quiz domain 1.3.2. Okay, let me bring up this other screen. And let me bring up that Zoom chat so I can see what you guys are asking. One sec. Okay, so question 1. How do benchmarks differ from high-level security frameworks such as NIST CSF? So A, benchmarks focus on business risk while frameworks focus on system configuration. It's kind of the opposite. Benchmarks are optional while frameworks are always legally required. Again, kind of more opposite. It's a little bit more nuanced. C, benchmarks provide specific technical configuration standards while frameworks define broader security outcomes. Yeah, that's C. Obviously not D. It's not only to cloud environments. So remember, that's like a benchmark is no, you must use AES 128. Well, a framework is just like, use this security in this industry, use this type of encryption, use this type of RBAC, not actually getting into the nitty gritty. So yes, C. Okay, question 2. Which statement best explains how compliance frameworks influence an organization's information security strategy? So how compliance frameworks influence. So A, they replace the need for technical security controls by focusing on documentation. Not at all. They help in both. B, they define structured expectations that guide how security controls are selected, implemented, and measured. I'm kind of looking more there. They guarantee, no, there's no guarantee in frameworks because it's just an ever-revolving door of cybersecurity. They apply only to regulated industries. Not true at all. A framework can be, I can own fucking Trader Joe's and I can do NIST RMF CSF. Excuse my French there. Sorry, I try not to cuss too much. So no, we're going to go with B. They define structured expectations that guide how security controls are selected, implemented, and measured. So yes, you guys are correct. Oh, cool. Only 2 questions there. I guess it's short, so I only did 2. Awesome. Another 100%. Okay, guys, I'm going to take another 10-minute break. When we come back, we're just going to finish up for the day, okay? I'm going to get through domain 1.3. And get through some of I'll get through domain 1.4 and then we'll call it for the day. Probably domain 1.4.2. And then tomorrow we'll be able to start a little earlier so we can get a lot more done. First day I'm just always like, it's a lot the first day. But okay, we're making good progress. Yeah, let's go ahead and take a 10-minute break.
No. Like you're live?
Yeah.
Oh.
What kind of dressing you want on your salad?
Balsamic.
They don't have that.
What do they got?
Blue cheese, Caesar, honey French, honey mustard, Italian, oil vinegar ranch, low fat ranch, and Thousand Island.
Honey French.
Juji, roast streaming, you can't scream. And mashed potatoes?
Yeah.
I don't like it.
Not for you.
I want mommy. I want mommy.
Go to your mommy then. You don't want to be on stream?
No.
Wow.
I break this for you.
What do you want on your mashed potatoes?
I'm sorry.
Just butter? Okay.
But I could make the penguin. They're not.
You didn't break him?
Oh yeah, we're about to eat tonight. Texas Roadhouse.
But they're for daddies.
Oh, the penguins for daddy.
My penguins, don't touch them.
Okay. Not for me.
Not for Amelia, no. That's right.
I'm gonna get you a penguin.
I don't want my penguins. I don't want my penguins.
Okay, I got it for 7:30, so I'm gonna end class at like 6:50. And then it's on the top of the cups. You have to get a ladder probably. Juji, I'll get her. Come on. Okay, let's go ahead and jump back into it. So we're going to finish up domain 1.4 today. Try to finish it before like 7 o'clock because I'm Ooh, this first day always wears me out. So we're going to finish up domain 1.3 here. Should be pretty quick again. Okay, so domain 1.3.3 of our SecurityX course. We're going to be going over these objectives here. So privacy regulations, and then awareness of cross-jurisdictional compliance requirements. Okay, so finally going over the GDPR in a slide. I've been talking about it this whole time. So the GDPR, just a quick overview. So the General Data Protection Regulations is a EU law that applies to any organization processing personal data of individuals located in the EU. Its scope is global, meaning organizations outside the EU must comply if they have EU customers. So if you have an EU customer, you must abide by the GDPR. The general overview of it. So GDPR requires organizations to implement appropriate technical and organizational measures to protect personal data. This directly affects security strategy by requiring encryption, strong access controls, authentication mechanisms, and regular security testing. So privacy by design and privacy by default, that's what it introduces. And there's a couple things that it does require. So it requires organizations to detect, analyze, and report personal data breaches within 72 hours. We talked about this earlier where like you have a reporting document or like reporting requirements or a data breach. You have to know how soon you need to report it and to the right entities. And then also there's like a right to be forgotten that's not listed in here that the GDPR allows for all of its EU customers, right? EU citizens really, is that there's a right to be forgotten. So you can request that an organization delete your personal data. Okay, CCPA, California's version of the GDPR. The California Consumer Privacy Act is a U.S. privacy law that applies to organizations collecting personal data from California residents. It's very similar. It says it's less prescriptive, but it still requires security controls and really goes over data privacy. And it has that same, kind of flow of GDPR. This last text bullet shouldn't be there. We're going to fix that on the fly. Okay, get rid of that. Let's go. First course of SecurityX. I should have done some QA, right? We talked about that. Okay, the General Data Protection Law. A quick overview. Even though L is first, LGPD. That's the General Personal Data Protection Law. So this is Brazil's. I think like Twitter or X had a problem. Not a problem with this, but I think they were going to ban Twitter. I can't remember. They had to do something with this. So Brazil's General Data Protection Law is similar in structure and intent to GDPR. It applies to organizations processing personal data of individuals located in Brazil. So the LGPD influences security strategies by requiring risk-based controls, data protection rules, and documented security practices. A lot of this is just like, remember the data sovereignty of it. So if you see LGBT, Brazil. GDPR, EU. CCPA, California. That's going to kind of be the biggest thing when it comes to the exam. Okay, COPA, or Children's Online Privacy Protection Act. This is a U.S. law. So this is designed to protect the personal information of children under the age of 13. It applies to online services and websites that knowingly collect data from children. So this is just saying you must have extra monitoring, auditing controls, and you must be aware and, enforce that, hey, if someone's under 13, there's an extra requirement and regulation that you must abide by. Oops, sorry about that. Now let's go over e-discovery, legal holds, and due diligence. So e-discovery, this refers to the identification, preservation, and production of electronic data for legal proceedings. So there may be something called e-discovery, which means that we need to do some digital forensics that may be admissible in court. A legal hold requires organizations to preserve specific data when litigation or investigation is anticipated. This affects our data retention. It affects our chain of custody, where we say there's legal hold, wherever that data is, okay, yeah, we got our hash for it. We make sure it's not tampered with. Now leave it. We can't tamper with or change this data because it's going to be used in court. Due diligence. Due diligence involves evaluating risk before entering partnerships, acquisitions, or vendor relationships. It's such a broad term. We use due diligence is a term used in so many different, facets of life, different industries, different career fields, not just cybersecurity. The way we do our due diligence a lot of time is like mitigating vendor risk. So doing our due diligence with vendors, but also doing our due diligence and assessing our own environment and seeing what, risk management frameworks and compliance regulations we have, data sovereignty rules that apply to us. That's due diligence a lot with cybersecurity engineers, kind of getting ahead of things. Due care, export controls, and contractual obligations. So due care refers to the continuous responsibility to maintain appropriate security controls. This includes regular patching, vulnerability management, monitoring and policy enforcement, and security training. So due care is kind of the next step. Due diligence is like, here's what we need. Due care is like, okay, now we must do it. Now we must say, we need these security controls and we need them updated. We need to be proactive in building them out and constantly reassessing and monitoring. Export control laws restrict the transfer of certain data, technologies, and encryption across national borders. And the DoD is a big one. If you're not a Five Eye country, you can't sell like munitions and certain defense products, or another country can't sell to America. So that's an export control. So some security strategies must include data classification, access restrictions, and sometimes geofencing to prevent unauthorized export of controlled information. Cloud architecture is one of those big ones because, in the cloud, it's all one portal where you can access multiple different data centers across regions. And obviously this, in the government, we have GovCloud. So obviously we're not going to have a GovCloud data center like in China, but there is still like Azure China. So it's just something you have to be aware of. Like, hey, are we an organization where I actually can't store things in an EU country data center because that data may relate to a product that I'm selling to the US government's military, and that's not a Five Eye country over there in Poland, even though maybe it should be. But anyways, organizations and then contractual obligations, this isn't a different definition than a contract between any businesses or anything. Something we have to just be aware of as that senior cybersecurity engineer, that organizations are often bound by contractual security requirements that may exceed legal mandates. So these requirements can include encryption standards, audit rights, breach notification timelines, and access controls. So essentially you're going into business with someone, they may have a cybersecurity clause in there that you as a cybersecurity engineer professional may need to read and assess, like, is this something we want to do or do we need to adjust? Okay, let's go ahead and do this quiz. So now we're going to do the domain 1.3.3 quiz. Let me just bring up my other screen here, guys. Okay. So question 1. An organization places a legal hold on certain records due to anticipated litigation. Which security consideration is most critical during the legal hold period? So we have A, ensuring affected data cannot be modified or deleted. So that's pretty much it, right? Disabling encryption, no. Reducing logging, of course not. Transferring data to a less secure system. Okay, these answers are, these ones are easy. Obviously A. So legal hold means don't touch it. Legal hold means that this is going to be used in court. It's going to be admissible in court. And we don't want to modify or delete it. Question 2. Why do privacy regulations such as GDPR and CCPA have direct impact on incident response strategies? Okay, so we have A, they limit the need for forensic evidence or investigations after breach. No. They require organizations to publicly disclose all security incidents regardless of impact. I think it said in there, no, that's not true. It said when there is risk. So you can have a data breach that where they exfiltrated no one's personal data. And I think the GDPR is like, you don't have to report it, if you contained it in time before it did that data exfiltration. C, they mandate specific timelines and processes for identifying, analyzing, and reporting data breaches. That's true. They allow organizations to delay response? Obviously not. So yes, this one's going to be C. They mandate specific timelines and processes for identifying, analyzing, and reporting data breaches. Question 3. Something about Brazil. So we can guess what this is going to be about. An organization operates in the United States, European Union, and Brazil. It processes customer names, email addresses, IP addresses, and purchase histories for users in all 3 regions. Which approach best aligns the organization's information security strategy with compliance requirements? So this one I think is going to be kind of different than what we've been explaining. It's going to be like, go to the most strict one and backwards plan from there. So like the GDPR is the most strict, based your hardening, whatever it is, your cybersecurity strategy off that, and then work backwards to be like, does that align with this? And more than likely, it's going to align with the U.S. for sure. Overkill for the U.S. But is this going to align with Brazil? So let's look at our options here. A, implement region-specific security controls that only apply when required by local law. No, it's way too crazy, way too hard that it just wouldn't be possible. It would be possible, you have multiple domains. But anyways, not a good plan. B, design a single strong baseline security architecture that meets the strictest privacy regulations across all regions. Apply encryption only to data stored within the European Union. Obviously not. Rely on incident response procedures. No. So yeah, B, design a single strong baseline security architecture that meets the strictest privacy regulations across all regions. Awesome. Another 100%. Okay. Moving up domain 1.4 now. Okay, so finishing up today, we're going to go over domain 1.4. So domain 1.4 is given a scenario, perform threat modeling activities. So now we're going to go over threat modeling. And in this section, we're going to be going over actor characteristics and attack patterns. So here is all of our objectives. And we're going to be going over the things in red. Okay, so threat actors and threat modeling, kind of just defining these terms a little bit more. So let me bring up my other window here. Sorry, guys. There we go. So at the core of threat modeling is the threat actor. A threat actor is any individual, group, or organization capable of intentionally harming a system, network, or organization. Hackers. This is a hacker. This is what, in the media, a threat actor is the person, the entity, whatever it may be that actually gets into your systems. And these actors, threat actors, are going to be labeled different things, and they're going to have a lot of different characteristics that define them, that define how we would describe them. So different motivations. Financial. So some threat actors have a financial motivation. They're either getting paid or the data they exfiltrate, they'll get money from. So financial motivation is a big one. And when they're financially motivated, a lot of times they're going after that financial transactions, or they're doing credential harvesting where they can log into your bank account, or they're trying to get those credentials to sell them somewhere else. Geopolitical. So other motivations, geopolitical, hacktivism, and notoriety. So 3 different characteristics that we'll define. So geopolitical motivated attackers are typically nation-state sponsored advanced persistent threat teams. So this is someone with a lot of time and money to do sophisticated attacks when it's geopolitical, because it's more than likely, it is sponsored by a nation state. Hacktivists are motivated by ideology, political beliefs. Their sophistication can range from low to high, just depends on who it is. But obviously, financial constraints, time constraints, resources are not as much as it would be of someone that's geopolitical, like a nation-state threat actor. And then some are just notoriety. Some are just, this is, I feel like, just a catch-all. Like, okay, if you're not a specific hacktivist doing this for moral reasons, if you're not a red team from a government, what are you doing this for? You're not in it for money. So this is kind of just a catch-all, just to do it, just to get notoriety, just to say, hey, I did this. Other motivations, espionage. So I like to think this is corporate espionage. So, they seek confidential or sensitive information rather than immediate disruption or profit. They want the IP. They want the data. They want something that's unique to an organization. Time as a resource. So attackers with limited time tend to use fast automated attacks and quickly move on if unsuccessful. So this is just saying, hey, this is almost like a script kiddie. We're trying multiple different things. We're attacking the entire landscape, that entire attack surface, through well-known, protocols that work on like unhardened networks. We're just going to see what works. Money as a resource. So money enables attackers to purchase tools, infrastructure, and expertise. This is just saying that some threat actors are well-funded. And again, that's mostly going to relate to nation states. This could work with corporate espionage, but I actually really don't know, but I guess you just don't hear about it as much. Corporate espionage at a high level, like corporations funding somebody, lots of money to hack their competitors. Maybe they do. Maybe I don't know. Maybe I should just take that back. But a lot of times in the SecurityX exam, when you see money as a resource, more than likely that's going to be nation states and advanced persistent threats. So capabilities. So supply chain and vulnerability creation. So capabilities describe the technical skills, access, and expertise of a threat actor. So the capabilities of a threat actor could be defined by their TTPs, historical information. Like we could use like the minor attack framework to be like, oh, this advanced persistent threat team typically attacks this OT infrastructure and they've been successful using these type of techniques. So supply chain. So supply chain access allows attackers to compromise systems indirectly by targeting trusted vendors, software providers, or service partners. So this is what we've been talking about. And like I said, it kind of repeats, but you don't always need to attack directly your target. They may have, other pieces to that puzzle. Their entire attack surface could be vulnerable supply chain or vendor risk. And then some advanced attackers are capable of intentionally creating vulnerabilities rather than simply exploiting existing ones. This is those advanced persistent threat teams. Like, it has this in here, but it's like, how many APT teams have done 0-day attacks? A lot, a decent amount. It's just not as common, but yes, some advanced teams can create the vulnerability. I'm not going to say it's not as common. It's just, there's nothing really you can do about it. All right, it's a 0-day. So attack patterns. So I have here the cyber kill chain just as an example. We're going to touch on that more later, just as an image example. Oh, sorry. But attack patterns describe the common sequences attackers use to compromise system. I look at this as TTPs. What do they do? How do they footprint? How do they recon? How do they exploit? Their persistence? Do they do lateral movement? Is their goal data exfiltration or persistence to have a back door? So understanding these attack patterns can help you build, that threat model to see where you can stop that threat actor in its tracks. So attack patterns may include phishing followed by credential thefts. It's just their TTPs, a whole slide to describe TTPs. Now, there are things and tools that can help you. So there are frameworks like the MITRE ATT&CK framework that can show you, hey, this advanced persistent threat team, this is their TTPs, this is their historical knowledge, here's who they worked with, here's the cases, and here's how to prevent the things that they'll do, like credential harvesting, privilege escalation, things like that. So threat modeling becomes effective when you combine all this, when you can say, hey, here's our industry, we know we're an OT industry, here's the potential threat actors, here's our attack surface. Let's use these different models to say, how should we start protecting or what do we need to be aware of? So we can implement that into our defense in depth plan, saying privilege escalation and credential harvesting is big in our field based off these hackers, these threat actors, and we can start to try to build that onion layer of security. All right, that was quick. Let's do a quiz. Go to my web browser here. Okay, so this is domain 1.4.1. Question 1. A security team is performing threat modeling for a healthcare organization that stores patient records and processes insurance payments. The team determines that the most likely attacker is financially motivated and has limited time and resources. Which attack behavior is most consistent with this threat actor profile? So limited time and resources. Let me pull up the chat here. A long-term stealth campaign? No. Automated phishing campaigns? No. C, manipulation of software updates? No. No money. He's broke. But it's financially motivated. So probably, ransomware. We didn't go into the slide. That's why I do like doing these. Ransomware is encrypt your drives and ask for a ransom. So they want that money and they don't have a lot of time or resources. So they're not going to build their own unique thing. So we're going to go with B here. Yeah, good job, guys. B. That is automated phishing campaigns designed to deploy ransomware quickly. Question 2. During threat modeling, a security analyst identifies an attacker who is highly skilled, well-funded, and primarily interested in stealing confidential research data without being detected. So it's an APT. They don't say the actual word, but it's advanced persistent threat. Which combination of characteristics most closely aligns with this threat actor? Financial motivation. They're well-funded, so no, right? Activists. They're not an activist. They want to steal research data, so it's corporate espionage. So yeah, we don't need to look at the rest. That's D. Espionage motivation with advanced knowledge and persistence. Okay, question 3. An organization discovers that malicious code was introduced into its environment through a trusted third-party software update. The attacker bypassed perimeter defenses and affected multiple systems simultaneously. Which threat actor capability best explains how this attack was possible? Trusted third party. Yeah, it's supply chain access. Easy. All right, awesome. So we got another 100%, guys. We've been killing it with the quizzes today. Okay, let me bring this up. Hold on. Okay, guys, so I'm gonna go ahead and end the class for today. I know